Already recording. Okay. So we're moving on to module 1, architecting fundamentals. Mainly it's access fundamentals. Anyone have any questions about anything I just covered or anything I talked about? Any doubts? Anything you want me to repeat? Be glad to do that. Okay. Okay, let's do it. So, interesting question. How far is your organization into your journey in cloud? Are you guys just getting started? Are you just like running prototypes? Do you have a bunch of production workloads running? Or do you want run 100% of your operations in the cloud? Anybody know? I suspect some of the leaders do.
I mean, I have production workloads running in AWS currently.
Okay. Are you guys using other providers or is it mainly AWS?
Mainly AWS.
And I'm assuming you have
strictly related to my desk. I can't speak to the rest of the desks.
Okay. And then I'm assuming then the rest of your workloads are probably on premise, like
Yes.
VMware, Hyper-V, simulation there in your own data centers.
Yes.
Okay, good. All right. I'm not going to make any comments about other providers because it's AWS class, but just to know that you know, Google in particular does some things very spectacularly. AWS though has the broadest set of services. So almost every startup, by the way, I consult with, if they started after 2012, which is about the time that AWS got really stable, for at least from my perspective, all those companies are 100% in the cloud. And nowadays, you won't find anybody running in a data center unless they have some kind of hardware requirement to do so. The economies of scale, particularly when you use the elastic features of like say Lambda or even EC2 if you're using autoscaling, are just so worth it that you never want to invest in hardware ever again after doing that kind of thing. Now, these are companies obviously that don't have hardware or security requirements that require them to be in a data center. There are quite a few, but most of them after 2012, regardless of their station, they're all in cloud. So good. Okay. So in terms of our call to action, the CTOs, like, hey, we want to understand the big picture of the AWS landscape before we get started. Like, what is AWS infrastructure? How do you protect resources? Because there's obviously a security or a billing implication, sometimes both, for almost every feature toggle that you have inside AWS. And there's a lot of questions. So how do we prototype? How do we get access? What are the basic services? And that's what we're looking for in this module, and in the next few modules, actually. So the objectives here are to answer questions like, how can I control access to cloud resources? How does AWS's global infrastructure organized? How do who is or what's going to control where the resources are going to exist, where data is going to exist, and where services run? And then how can we make sure that everything is built according to best practices? So, and then of course, right off the bat, we sticker shock you with an awesome diagram, which is a pretty like basic solution inside of AWS with a traditional, in this case, it's not really a triple tier app. It's really a 2-tier app. Let's take a look at some of this. So to start, note that like your primary hosted application is up here. There's no, the web server could be stacked on here, but the presentation layer and the application layer, if you're going to approach it that way, are right here. And then notice that right here and here are where your data layer is, basically, right? Your persistence layer. All the rest of this is either caching, which is what this is. This also could store persistent data, just like files that are shared across all the app servers. So just know that EFS could be storing persistent data. It could be HTML files. It could be, whatever. And then note that they are using both a load balancer and an auto scaling group, particularly with the app servers in order to make it elastic. So you can scale down to business continuity minimums or just scale up to as many servers as you're willing to pay for in a single availability zone or region actually. And then notice that there's a bunch of networking components here. So if we look, they've got a NAT gateway for basically traffic outbound from the servers. They got an ELB, which is going to actually distribute traffic to the various systems. And we don't know whether that's a network load balancer or an application load balancer. It's probably not a gateway load balancer. And then notice that there's an internet gateway, which is actually part of a VPC. And then there's a bunch of kind of edge services like CloudFront and Route 53 active, which are doing DNS and of course some content distribution, across the entire world or whatever section of the world you want to specify. And then notice also that S3 is out here. S3 could also be doing some hosting. So S3 could be hosting all the video files and the images and all the static content, whereas the app servers could be over here hosting the dynamic content. Notice that there's an availability zone here, an availability zone here, and this is all within a single region. So this is not a multi-region setup. This is just a single region. So this is either Virginia or Ohio or Oregon or California or Sao Paulo in South America, or it could be Frankfurt, it could be Ireland, it could be a single region with at least 2 availability zones being used. So this is considered best practice to use at least 2 availability zones in any region. If you want to go multi-region, you're going to have to deal with the latency problem, especially around state replication. So replicating your databases can be a little bit challenging in that context. So this is a drawing of a potential architecture that's pretty standard inside of AWS. Now, this should be a complete mystery to you unless you're familiar with AWS services. But by the end of the course, you're going to know what every single service listed here does. And in your capstone lab, you're actually going to end up setting up a fair bit of this. So you're going to get some exposure at making this work. So we're going to talk about some services, the AWS infrastructure, and the well-architected framework, and then we're going to do a lab where you're going to explore using the AWS API to deploy an EC2 virtual machine. Now, these are the 3 kind of sub-modules that are inside this module, which is all about, architecture fundamentals. So let's talk about services first. Which AWS services should I consider, and how do I manage them? So just know that Amazon has regional data centers. These are collections of data centers. So think of these as like meta clusters. These are clusters of clusters. Amazon has regions located all over the world, and there's even more than what's listed here, actually, even now. So they have global data centers all over the world. The collection of data centers is called regions. The data centers inside of them, the clusters of data centers inside of them are called availability zones. So you've got regions like US East 1, which is Virginia, or US East 2, which is Ohio. And then inside Ohio, for example, you're going to have 3 clusters of data centers, and those are called availability zones. Availability zones make up a region, but just be aware that regions have their own data centers that you don't have access to. And this is where regional services such as S3 or DynamoDB live, because they don't live inside the availability zones. They live inside these hidden data centers called regions. Amazon has over 300 services at last count. If you kind of like macro them out, I think it adds up to exactly like 281 or something at that point in time. But if you micro them out, there's thousands of them. Meaning, for example, CloudWatch is a macro service, CloudWatch. CloudWatch has 11 sub-services underneath it. CloudWatch logs, metrics, alarms, service map, insight, canary insights. It's got all kinds of services underneath it. So these services run for the most part all over the world. There are certain regions where certain services don't exist, But in the United States, almost all new services are either started in Virginia or they're started in Oregon. So if you're in those two locations, invariably you're going to get you're going to be one of the first data centers to inherit a new service. Now, customers like this because, one, this allows you to go global really fast, because you can give back hardware when you don't need it anymore. That's on demand, right? You literally can just pay for what you need and then give it back when you're done. You want to do a proof of concept with 1,000 servers for an hour? Great, do that, give them back, you're done. So this does allow you to scale pretty seamlessly. And if you want to get into a relationship with Amazon and get a discount off the retail price, you can. If you don't want to pay $1 an hour for a 4-processor 32 gig server, which that was a little bit of an exaggeration, probably be more like 16 processors and 64 gigs of RAM for $1 an hour. If you don't want to pay a full $1, then there are other options that will get you down to 10 cents an hour, other options that will get you down to 40 or 50 cents an hour, and other options that will get you down to 60 or 70 cents an hour. Just know when we cover EC2 in particular, you're going to see the different licensing types that allow you to get cheaper per hour discounts off the same box. So customers look at cloud in general, but AWS in particular, because, one, you can operationally offload a bunch of stuff. You're not going to get woken up at 3 o'clock in the morning for a failed disk anymore. Amazon's going to handle that for you under the covers. You won't even know that the disk failed most of the time. You're not going to know the network switch failed. You're not even going to see it. It might be half a second blip, maybe less on your system. That's it. And if Amazon controls the device, meaning they can log into it, but you can't, they're responsible for defending it from a security perspective. So if you go completely serverless on one of their services and you can't log into the servers or you don't know where they're at, Amazon's responsible for defending the servers. Their security team is pretty good at it. Out of the three, I would say they've probably had the least security incidents, although Google's not far behind them. Azure just hasn't really done that great, honestly. Here's the service categories. So note that we're not going to talk about machine learning. We're not going to talk about like Pinpoint or Connect, which are like customer engagement tools. We're not going to talk about Glue and Athena. Those are all analytics tools. We're not going to talk about Lumberyard, which is game tech. We're not going to talk about Ground Station, which is satellite. We're not going to talk about the RoboMaker. Oh God, I can't remember the name of the robotics one now. We're not going to talk about any of that stuff. We're really just talking about core infrastructure. Compute, networking, storage. That's pretty much it. And we'll talk about some database applications, which is why we're going to talk about database. And we'll talk about some messaging applications like buses and queues and stuff like that. But that's it. Buses. Did I say buses? I meant queues and notification systems, not buses. They don't use buses a whole lot anymore. Now, an architect in general is responsible for planning, researching, and to a lesser degree, supporting the build, but not necessarily doing the build. Now, I say that I think it behooves every architect to build the infrastructure that they're suggesting downstream, or getting the downstream folks involved with the prototyping and all that stuff right off the bat, because you really don't want to throw your design over the wall and not ever having like put it together, at least at some scale, right? So just know that these are the activities that we're going to focus on: is the planning, the researching, and the ability to build. Because it's important as an architect, especially a solutions architect, which is kind of middle of the tier between a systems architect, right, and an enterprise architect. You've got solutions architect, and solutions architect tend to live at the boundaries or the integrations of services. So Amazon's really interested in that, because hooking services together is where the magic is, and this is where also the pain points are. Enterprise architects tend to be too abstract and are more focused on strategy. And systems architects or software architects are more focused just on their individual application. Solutions architecture is more about how do all these Lego blocks fit together? How do I create a flow of experience for a customer, including the app that the systems architect and the software architect have probably worked on. So planning, researching, building, important pieces for a good architect. This is the sample design that we saw earlier. So important to stay connected with this, because an architect with AWS must know what services are available to fill a particular role and how they interconnect. And if you don't know what the icons are on this diagram, you shouldn't. Most of you should look at this and be remarkably uncomfortable. You're like, I have no idea what any of that meant, Michael, when you talked to ELBs and all that earlier. No idea. Good. You're in the right class. So we're going to cover all of these services. So just think of this right now as a roadmap that we're going to build piece by piece to outline a particular like software system or design. So we're going to talk about the relationships, the constraints, the boundaries, all on how to bring this all together. Really, that's what we're going to be focused on. Okay. Any questions thus far before we talk about connecting to AWS services? Haha. Okay. All right. Here are the three sacred ways up the AWS mountain, right? If you want to talk to an API, well, there's a couple options. Because remember, this is all software-defined infrastructure. This is all API-driven infrastructure. So if you want to talk to an API, for those of you who are programmers of any type, you know obviously that you can do it programmatically, right? This is where things like the software development kit at the bottom left-hand side, CloudFormation, which allows you to just take a single YAML or JSON template and define a bunch of infrastructure, or the CDK. This is where this all lives, right down here. With the CDK, by the way, you can take Python, TypeScript, Java, C#. You can actually just write out code using these things called constructors inside of the CDK that will, in like 2 lines of code, you can define an SQS queue. 2 more lines of code, you could describe an SNS queue. 2 more lines of code, and you can link the SNS queue to the SQS queue. 4 more lines of code, and you've defined 50 EC2 instances. So if you're from infrastructure like me, you're probably like, I don't code. I'm going to say this. If you're going to stay in the industry for the next 5 to 10 years, I don't need you to be a feature programmer, but learn Python. I could not emphasize it enough. Go out there and learn some Python. I don't need you to be able to write an application, but I need you to be comfortable hacking out some Python, because this is now the new literacy. This is the new base level of literacy. And I know I fought it for a long time, but then, not even like 8 years ago, I started acquiring a certain level of expertise with Python, and it's pretty much all I live in now, even beyond bash scripting, which is where I spent most of my time prior, right? So if you've been fighting it, just let someone tell you right now that if you can learn how to hack through some Python, it's going to change the nature of how you do things. And you absolutely must be code conversant to use AWS effectively. The management console is a great product to test visibility and to learn, but the CLI and the software development kits and the CDK and all that down there are where scale happens. Nobody logs into the console to launch an entire infrastructure. It's all done either through a CDK, SDK, or you can do it through the command line, although that's actually harder. It's harder to do it through the command line than it is to write some code, frankly. Just because there's all these flags and parameters you have to get right. If you mess them up, the CLI is unforgiving. So those are the 3 ways you can access AWS. You can use the existing product of the management interface, the web interface. You can use the CLI, which is also a prepackaged product, or you can import CDK and SDK libraries, write some CloudFormation, throw that into AWS and let it create the objects that you're looking for. All right. Now the management console, which is probably a useful segue. Where are you, management console? There you are.
Real quick, before you jump into the next thing, if you don't mind.
Yeah, go
I
ahead, Dave.
love Python, but I was just wondering if there was a major reason why that was kind of your first recommendation over something like Terraform.
Well, Terraform is super proprietary, right? So, and Terraform's not so, to say this is like Terraform is its own proprietary syntax, and that's not gonna. Terraform has so many limitations when it comes to like conditionals and loops and whatnot. And I teach Terraform classes, right? So this isn't just me pulling it out. Just know that there are so many incredible limitations to Terraform that does not support programmatic, constructs, and doing it in a programming language is going to be much more efficient. I'm not a fan of Terraform because it locks you into HashiCorp's proprietary language, into HCL, which again, Terraform has got to be the most popular tool. And it really blows my mind as to why Terraform is the most popular tool, because it is so incredibly limited. It's very finicky to use. Doing state management is a pain unless you had another thing like TerraGrunt, or pay for the enterprise version, which I think they made free recently, but still it's still a pain. And in addition, you don't get all the flexibility that you would if you could actually just use a full programming construct. And not only that, you have to define a Terraform file for all the cloud providers that you're going to use anyway. So then what did you gain? You used a proprietary format. You added state management in there that you're going to have to figure out yourself, which you could have just used a Git repo for. And then you're going to basically have to write a file for every single cloud provider. By the way, if you use the software development kits, you'd be shocked at how much reusable code you actually have in Python, as an example, if you did that. Now, my go-to is actually Terraform when it comes to infrastructure as code, but I'm starting to see the benefits of using Python a whole lot more while getting away from some of these proprietary tools that kind of lock you in and don't give you all the flexibility. So, fan of Terraform, but I got to tell you, if I was starting over, I probably would just go straight for Python and use one of these software development kits, because the reusability is just incredibly high. I don't know if I answered your question.
No, that's perfect. Thank you.
Yeah. And the funny thing is that Terraform has been the unchallenged infrastructure as code tool for pretty much the last 10 years, right? But if you ever get onto the Slack channel for Terraform, you should hear people complaining about its limitations. It's just
no doubt. Actually,
really...
it was, to be honest, like there's a couple of us that share that sentiment, so we just enjoyed hearing somebody else say it too.
I'm sorry, Terraform is perfect, and you should use that for everything. That's what I'll say from now on. Yeah, that's good. Yeah. Other questions? Oh yeah, we were here at the console. Amazon has switched this a lot recently. What was I doing out here? So when you're in the console, by the way, a few things to note, and I'm just going to give you a fair warning. When you do your labs, the console has this funny thing where it just will change the region on you. So remember we talked earlier about how regions are these like meta clusters of data centers, and inside each region is an availability, like sets of availability zones, which are actually clusters of data centers. So this is the region definition where it says Ohio, Virginia, Northern California, et cetera, et cetera. Notice that not everything is listed here, because sometimes you have to apply to Amazon to get access to, say, like China, for example. But notice that you'll be working in Ohio. You'll be kind of like working away, and you're like, la, 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 working away in Ohio. And you'll go to look for something, and you'll realize that it's not there. And you're like, I stuck it in Ohio. Like, what's the problem? Well, what happened is that you may have missed it, but like you were probably actually working in Oregon, and it just switched on you. So when you do the labs, please get in the habit, because you saw me set it to Virginia, right? So you all saw me when I went in there and I set it to Virginia. Get in the habit of looking up here to make sure it still says Virginia up here, because sometimes the console will just change regions on you. I've written AWS about this several times. I've had talks with their product, the console management product team, and said, hey, they're like, yeah, we know. We're not sure exactly what causes it to switch. We haven't figured that out yet. So go figure. But this is where, by the way, the console home is where you would find like just a general dashboard, and you can add whatever widgets you want here if you want to. But this is also where it will show you everything you've recently visited. And this is also where you would find services. Now, the cool thing about the search is that if you're like, hey, you know, I really love MongoDB, you can actually type in MongoDB and it'll give you the compatible service. That's another one, Cassandra. Like, hey, I really love Cassandra. It's like, okay. Or your what was Chris asking me the other day? Oh, Kafka. He was like, hey, Kafka. And I was like, oh yeah, that's MSK. That's a managed service for Kafka. Notice it also mentioned Amazon's proprietary streaming service, Kinesis, which is not an industry standard, right? Let's say you're like, I wonder if they have a RabbitMQ service. It's another one. What's a weird one? Neo4j. They have Neo4j. Well, this doesn't list the service, but it's actually Amazon Neptune, which is Neo4j compatible, right? So that's the console. Now the CLI. Oh, don't open over there. Open over here. Oh, wow. Hold on. That's not what I wanted. There we go. The CLI, if let's blow that up a little bit. So I'm using a shell called Starship, by the way, in case people are interested. It's starship.rs. Starship is a Rust written shell. Because I work on all three operating systems, I just normalize my shell against Starship so that it like all lists the same thing. So so if you're here, by the way, and I'm not going to go in any particular directory, but let's say that I was worried about whether or not I was running EC2 instances in US West 2. Like I was like, did I leave anything running? What you can do is you can just run the command line. The command line is prefixed with AWS. And then usually what happens is you follow it with a service. So like RDS, for example, or let's say I wanted to see all the S3 buckets that I had inside my listing. By the way, you'll find weird names in here for me for the buckets because they have to be global. The names have to be globally unique. So sometimes I throw in weird things like goat or dead hot chili peppers or something weird like that because I want to make sure I can get something that's globally unique. Where's someone here? New goat bucket or whatever. So just know that the AWS command line is usually set up with AWS configure. We'll actually be touching some of that later. And you do have to actually have basically what's a username and password in the form of an access key and a secret access key. And think of them as almost like a two-part API key, if you will. And you do set your region, and then you can also set your default output format. YAML is only shows up in like version 2 dot something of the command line tool. So if you're using 1 dot whatever, you won't get YAML, just so you're aware. But if you can still use JSON if you want to use JSON as an output for your tool. You'll see all this when you set up the labs, but just know this is the second way. And then third way, actually, hold on. Where did I stick that? Let's see, did I stick it there? I think I stuck it there. I think that was right, yeah. You know, the third way would be like you could come in here and define like constructs in here, like SQS constructs. Now you'd have to actually import SQS in here. You know, things like that. You'd have to like set, you know, the different like you have to import the different libraries, and then you could actually just create objects, and then you just it's like 1 or 2 lines of code, and you just set up SNS, set up SQS, set up a subscription. It's just that simple. And then this becomes super reusable, and you can just do one template to set up everything. Obviously, you could also do CloudFormation if you want to do that as well. CloudFormation is proprietary to AWS, so the syntax is something that you'd have to learn. But I would say if you had to choose between CloudFormation and Terraform, learn Terraform because at least then that could be semi-applicable to other cloud providers, and you get a little more portability. CloudFormation is really just a flat file that you submit to a service, and you'll see that when we get to the section on automation. But that gives you kind of a general idea of like the 3 ways in which you can actually access and define infrastructure in AWS. All three of these, whether you use the CDK or an SDK, whether you use the command line or whether you use the console, these are all just vehicles for accessing the API. So it shouldn't be any great mystery there. Most of our time is going to be spent inside the console because that's the best way to learn. We will spend some time inside the CLI. If you want to get your hands into the SDK, CDK side of things, do note that at the very end of this class, before we do the capstone lab, I'm going to give you a list of training resources so that you can go deep dive into whatever topics you want to at your discretion. So I'm going to show you where a bunch of free labs are that are written by AWS that are freely posted that you can go and deep dive into whatever subject you need to. So if you need to deep dive into security, you need to know more about automation, I'm going to make sure that before you leave Architecting on AWS, this course on Thursday, you're going to have a list of places that you can go to get the labs you're looking for to deepen your experience of AWS. Okay, so this is just the tip of the iceberg. Questions about accessing AWS at this point?
Hey, Michael, quick question. I'm trying to differentiate between CDK and SDK. Is SDK the way you access already deployed resources? Like, for instance, if I'm using Python, would that be Boto? And CDK would be what you just showed us?
Yeah, so think of it this way. So if you put CloudFormation at the top and then CDK and SDKs, think of these as abstraction layers. So CloudFormation is probably one of the most simple ways because you're not really writing code, you're just defining the configuration, right? So it's declarative, right? And so, you know, you're declaring a file and then just having the service ingest it. So it's using, you know, whatever it's using under the covers, but all you're doing is just writing a declarative file. With the CDK, it uses Boto, which is the SDK under the covers, but it abstracts a lot of that away so that you don't have any of the low-level interface interaction. You define an object, some parameters using the constructor path, and it just eats it, and then it uses Boto to convert everything over. And it actually writes CloudFormation, oddly enough. So it's kind of weird how it does that. And then, of course, when you use the SDK, you're using pure Boto if you're using Python. Boto, by the way, is the name. Boto 3 is the Python library, right? That the SDK library for Python, for AWS. In that case, you are purely defining it based on Boto's documentation, and it requires a little bit more like coding expertise to actually like define that because you're actually doing that at a lower level than you are at the CDK. So just think of that as levels of abstraction. The CloudFormation is at the top. CDK is kind of a middling level of abstraction away from Boto 3. And with Boto 3, obviously, you know, I know that you have both lower level and higher level in Boto 3 access, but it is the most like raw way for you to actually get access to the API. So just think of it that way in terms of levels of abstraction. They're all used for the same thing. CloudFormation can manage existing resources. It can launch new resources. CDK can manage existing resources. It can launch new resources. Boto can do the same thing, right? You can actually import and see what's already there, take it over if you want to, make it part of your object declaration, and then you can add new objects to it to launch further systems. Now, there's a lot of programming you'd have to do that with the SDK, with Boto in particular, but with the CDK and with CloudFormation, that's just an importation at that point. Does that help, Rakesh?
Got it. That answers my question. Yeah.
Good. Okay. Heading down this path. So we got the management console, and the CLI and the CDK, SDKs, and CloudFormation. Do note that Amazon makes a big distinction, just switching gears, so switching topics for just a second, between managed services and unmanaged services. So an unmanaged service means you are responsible for almost all aspects of management. That includes operating system patching, database, like application patching, like if it's a database application or whatever it is, right? And everything basically from operating system management and above. So if you can log into the operating system, then you're doing an unmanaged service. Now, fortunately, there's only a few unmanaged services. EC2, obviously, anything that is the underpinnings where EC2 is underneath it, like you can actually roll the container services ECS and EKS unmanaged. So you can actually manage your boxes if you want to. You can log into them. when you can log into the box, you're probably doing an unmanaged service. EMR has the same thing, right? So if you're using Elastic MapReduce, if you can't log into the server, like RDS is a great example. RDS looks like it uses EC2 to launch databases, but you can't log into the operating system because Amazon manages that whole thing for you. So you know what size of box you asked for, but you can't log into the operating system, but you can manage the database all day long if you want to. And Amazon will patch the database for you based on parameters you specify. So you're not even really responsible for application patching either. A better example of the highest level of managed service would probably be either Lambda or DynamoDB. DynamoDB, you just set up your table construct for your data hosting. You tell it how many read and write capacity units you want, and then you let it go. All of the underlying servers, all the patches, all the database backups, all the high availability, all handled by AWS. So just know that there are unmanaged services that are infrastructure as a service. And there are some managed services that are platform, meaning they don't go all the way to the top in terms of management. And then there's some managed services that are like SaaS. And DynamoDB is like that, right? You just set up a data receptacle, basically a table, and you put your data in there, go to town. You don't have to worry about any of the stuff in gray here. You're just worried about optimizing that application for your usage. That's it. So just know that AWS's general recommendation is always going to be get away from infrastructure as a service, move away from platform as a service, try to use software as a service as much as possible. In other words, you want to go for the most highly managed services that you can get on AWS from AWS's perspective. Just to ask you all this, what's the cost though to the business technologically if you use a highly managed service? What's the problem with that? What could be one of the cons of using a highly managed service?
Control,
right? Another way sometimes I hear people talk about that is vendor lock-in, right? So and they can be two different things. Jeremy, to your point, you have a lot of control if you have control over the infrastructure. So that's true all the way up until you get to PaaS and SaaS. But the other thing that this represents is that if you decide to run virtual machines across all three cloud providers, that's going to be a similar experience for you. Just like if you decide to run Kubernetes across all three cloud providers, as long as that is a CNCF certified distribution of Kubernetes, your experience is going to be predominantly the same. But if I decide that I want to use a serverless NoSQL database in AWS, and I want to do the same thing in Azure, and I want to do the same thing in Google, I'm going to have vastly different experiences because those are all API-driven databases, and those APIs are all very different. Kubernetes uses the same API across all three platforms. And if I'm running, let's say Ubuntu 22.04 across all providers, my experience of managing that operating system with a few caveats for the disk and the networking and the firewalls and all that other stuff is going to be predominantly the same. I'm going to patch them all the same across all three environments. So just be aware, though, that by running everything as an infrastructure as code level, that is the most inefficient way to use cloud. You are going to spend the most money running your operating systems across all three providers or two providers or even in one provider. You're going to spend the most money doing that versus if you run it as a software as a service. So you got to weigh the pros and cons against the business, because unless the company is just super scared of investing in with one or possibly two providers, you're going to want to go all in on managed services, because that's where the most money is going to be saved and that's where the most operational offloading is going to happen. But if that frightens the business, if the business cannot stand the risk of that because they're thinking, well, we want to be able to pull out of this in 6 to 18 months, then you're going to have to go down to platform as a service or go down to highly unmanaged services such as EC2. Does that not make sense to anybody, or does anyone have any questions about anything I just said there? Good. I'm not the only one having these discussions. All right. speaking of highly managed services, remember we talked about Lambda before as being one of the like serverless, like its functions as a service. This is one of those ways you can host applications, but it's really like a slice of an application because it's like a function. It's not really a full blown. It's not a containerized application. It's not an operating system application, an application inside of an operating system. Serverless is really slices of an application. This is where event-driven architecture takes over, right? Serverless services or DynamoDB or S3 or services like this, these are the highly managed services. They don't operate inside of a VPC. And you might say, oh, Michael, wait, what's a VPC? A VPC is like the networking portion of your account. And by default, you can have up to 5 different networking segments inside of your AWS account. So all of this, as you can see here, all of this VPC box right here defines that all of this networking is all controlled within a single partition inside your account. And notice it's inside of a single region. So in here, notice that RDS is running here because it uses EC2 underneath it. This uses EC2 underneath it. This uses EC2 underneath it. Because any operating system is going to require a network card to function. Now, if you use something like Lambda, which is serverless, you don't see the operating system. Amazon controls that. And so it runs off in its own data center outside of your VPC data centers. So somewhere over here, they're running their own little Lambda functions out in their own regional data center, and it is outside of your VPCs. This is important to know because technically all of this is in the same region. I should probably do that in pink just to make sure. All of this is actually in the same region, but you're like, Michael, what is this little data center right here? This like one that you're talking about in the upper left-hand side. There are these hidden regional data centers. Remember, I mentioned this before. In every region, Amazon has hidden regional data centers that host their regional services. Serverless, which is Lambda, DynamoDB. There's a bunch of others. S3 is another one. They all live in this hidden data center. So just be aware that when we talk about VPCs and data centers, we're mainly talking about data centers that you control, but there are data centers out there that you don't control in every single region. So there's some in Virginia, there's some in Ohio, there's some in Oregon, and they provide all the regional services. Now, just to add insult to injury, by the way, serverless can actually be inserted inside of a VPC. So if you want to attach it to a network card, you could actually just stick it inside of your VPCs if you want to. That's a relatively recent feature in the last few years. But Amazon's really big on allowing you to keep everything inside your VPC. And so over the last few years, they've been allowing you to stick these services that live inside this little hidden data center. They'll give you a little secret like network link that will allow you to take this service and run it as if it's inside your data center. They'll allow you to take this service and allow you to run it as if it's hidden inside your data center. I know the abstractions just keep going, but don't worry, this will make more sense as we go on. Do note, by the way, that Amazon's documentation is pretty solid. So you're going to get access to a bunch of really solid documentation inside AWS. So, you know, it's not perfect by any stretch of the imagination. Usually find, you know, even last week I was doing something, I think it was on the CDK actually, and there were errors inside the documentation, but they were easily fixed if you just follow the error message. So, but for the most part, 95% of the documentation is just rock solid. So it will help you get to where you need to go. This is usually, by the way, docs.aws.amazon.com. Let's see. You type that out. This is actually in your student guide. There you go. So this is in the student guide. This link you don't need to save. Okay. So that was just all about AWS services. Let's dive a little bit deeper into the question of where, Michael, you keep talking about these hidden data centers and availability zones and VPCs and whatnot. where do my services and where does my data live? These are the questions I need to answer, right? Let's talk about it. So a reminder that Amazon has data centers. And remember, a collection of these collections of data centers is called a region. So Oregon, Northern California, Virginia, Ohio, in the United States alone. Every single region is made up of at least 2 availability zones, and these are clusters of data centers. So you can see down here, there's 3 data centers that make up this availability zone because they are clusters of data centers. These availability zones, if you will, they are independently cooled and they have independent connections to the internet. So you cannot cut them off from the internet. They have their own independent connections from the internet, usually dual. And if one of these guys goes down, Amazon's best practice is to always be running at least 2 servers at any given time. Let's say you add one here and one here, so that in an event that a cluster of data centers fails, you can fail over to the other system or just beef that system up so it can handle 100% of the traffic. So note that these 3 AZs right here, availability zones, make up the region. Now, don't forget what I said earlier. There's a hidden data center up here that's also part of the region that hosts all the regional services. There's actually a series of them, just so you know. They all make up the region, but Amazon didn't talk about that, so that's just me telling you. Okay. So these guys are designed for fault tolerance. So if one goes down, the other 2 take over. Now, regions are all over the place, right? Notice that Auckland and Sydney and Melbourne and Hong Kong, Osaka, Tokyo, they're all over the place. There are government versions, GovCloud East and GovCloud West. And these regions, by the way, are completely independent from each other. They do not talk to each other by default. You have to set that up if you want to. You can actually route between the different regions if you have your application running in multiple regions. You can use something called Global Accelerator to do that. You can also use DNS to fail over to different regions if you want to. Now, why would you choose one region over another? All right, here's the 4 general reasons why. 1, Amazon just launched a new blah, blah, blah service and I want to run it. Well, what did I say was the 2 places where Amazon's going to launch new services? Where are the 2 regions where Amazon typically launches new services? Someone tell me this.
Virginia and Oregon.
Exactamundo. Exactly. So service availability is probably one of the first reasons, right? But I will tell you this, is that serviceability is always trumped by governance. Like people in like, we operate, mainly in Europe and we have to keep our data over there in Europe, right? We're not going to host it in the United States, right? Because for the reason the companies won't allow that. Or vice versa, it's on the United States and so the data can't be hosted somewhere else. Governance will always determine pretty much first where you're going to run. And so those are usually the first people you talk to. Second is typically who's your audience. My nephew recently decided to launch an anime list website because he really loves anime, which I was more than glad to support that for him. He launches it in Virginia, and then what ends up happening is that a bunch of people in Japan start using his service and they're complaining about latency. What do? He put another version of it over in Tokyo, right? So just know that you want to put your services closest to where the bulk of your users are. So just something to be aware of. And then last but not least is cost, is that typically on every continent, there's going to be one region that's more expensive than the others. I'll give you an example. If we go to, I wonder if the simple monthly calculator is still up actually. Let's go take a look. Are you still up, simple monthly calculator? You're always fun to use. Amazon's been trying to retire this thing for a while. I don't know if they actually got to it. Nope, they haven't. There's another website, by the way, called calculator.aws. It's not as fun, but it has more functionality. So we're in Virginia right here, right? Let's say that I want to just use S3 standard storage and I want to store a terabyte. How much is that going to cost me? Well, $23.44. Straight up, right? Enterprise class storage, 11 nines of durability, super fast. That's cool. Let's hear that out for a second, though. Now I'm going to switch over to Northern California. And I'm going to do that same 1 terabyte that I did before. That went up by $3.06. Is that over 10%? Looks like it. 10% looks like it would be 265. That's yeah. So 230, something like that. It's well over 10%. So my point being is that Northern California, by the way, is usually 10 to 20% more expensive than any other region in the United States. As a general rule of thumb, don't do things in California unless you have a customer that absolutely requires you to do things in California. Every continent has something like that, by the way. It used to be Tokyo. I think they've gotten better, more efficient at that, but it used to be that Tokyo was the bad boy in APAC. Let's go take a look at Hong Kong was also another challenging one. Let's go take a look at Sydney. So we're in Sydney. Let's say I do a terabyte of storage over here. What's the cost? $25.47. Okay. So let's zero that out because we don't want that in our total costs. And $25.47 for Sydney. Let's switch over to I don't want to do Osaka. Where's Tokyo? Let's do Tokyo and see if the price has changed. Nope, it's the same. So they fixed it. So let's try Osaka just in case that was not fixed for Osaka. Nope, it looks like they normalized all the rates. Used to be that Tokyo, like I said, was more expensive. But we'll check the last one and then we'll move on. Hong Kong. Nope, they normalized all the numbers down to 25.47. So I'm not sure who in APAC anymore is now the most expensive, but just know that Northern California is the most expensive. And it used to be Frankfurt and the EU, but they normalized that as well. So just be mindful. You might want to compare prices every once in a while. Northern California is consistently more expensive. No question about that. It looks like they normalized the other data centers. So just be aware that there are more expensive data centers. So cost is another factor in addition to latency, in addition to service availability, in addition to governance. Now, Amazon got a wild hair and said, you know what? Instead of building these big regional data centers with these availability zones, what if we just took an availability zone all by itself, just one cluster of data centers, and we stuck it in every major metropolitan area? So we stuck one in Chicago, we stuck one in Atlanta, we stuck one in Denver, we stuck one in Austin, right? So AWS has this concept of local zones. And what this is that these are single like data center clusters, like data centers that AWS has launched, and they are not redundant, meaning if they fail, you have to fall back to a region. Meaning if you decide to use the local zone in Boston and for some reason it has an outage, you have to fall back to Virginia. If you decide to use the local zone in Los Angeles, you have to fall back to Oregon. You might say, well, Michael, how come they don't fall back to Northern California? I have no idea. I think Amazon's going to retire Northern California. But here's a list of all the single availability zone, also known as local zones, data centers that they have launched in the United States. So you can get single digit millisecond latency in your home city if it has a local zone inside of it. But remember, if you need redundancy, you're going to end up falling back to the parent region. So Las Vegas, for example, has a local zone, but it falls back to Oregon if it fails. So Gonna weigh that out a little bit. So notice, I think there's like 34 listed here. Oh, there's the announced ones. So Denmark, India, Argentina. Oh, it's ridiculous. So I think they've got 34, if I remember correctly, 34 announced total local zones that are launching to. Now you can run EC2, you can run RDS, you can run most of the core applications inside these local zones. So, but your redundancy is going to be back at the region. So make sure you check the list to see what it's going to fall back to, because it might surprise you. For example, it might surprise you that, where is Los Angeles? Los Angeles is over here. Los Angeles doesn't fall back to Northern California, falls back to Oregon. Okay, so just keep that in mind when you're architecting. Is it acceptable that you might go from like 7 milliseconds of latency to 27, because now you're going from Los Angeles, now you're falling back to Oregon. So just test all that. So local zones are right here. I don't know if there's a really great link for that, so I'm actually going to post this in the chat so you can have it. Best way to think of these is that these are latency sensitive applications located in city specific data centers. Boston, Los Angeles, Austin, that kind of thing. So local zones are really close to major metropolitan areas. Okay. So in addition to regions, which have availability zones inside of them, in addition to local zones, which are just single availability zones that are in a major metropolitan area that don't sit inside of a region. So local zones just sit outside of a region in a major city. They also have what's known as edge locations. Now, what's the distinction? Regions and availability zones are collections of data centers. A local zone is a single collection of data centers. Edge locations are either a server or a rack of servers. That's it. You might say, Michael, what use is a server or a rack of servers in relation to a global infrastructure? Well, this is where all the DNS magic happens, right? This is where DNS resolution occurs. This is where all of your caching happens. So when you want to cache a bunch of cat videos, because you have a deep and abiding love from the 90s for cat videos, or 2000s, whenever, I'm not here to judge, right? And so you have a deep love for cat videos. If you want to distribute those the world over, you might turn on CloudFront so that copies of your cat videos can be brought closer to the users. Well, those copies are run on top of these cache servers. These are called edge locations that are all over the world. And Amazon got really smart about this. Just like the way they run local zones in major metropolitan areas, they stuck a server or a cache of servers at every single major ISP in the world. That's a great place to run caching because everybody's got to go through there, right? So where all the tier 1 to tier 2, tier 3 conversions happen on the backbone, they have typically stuck some kind of server there to act as a caching mechanism so they can push content closer and faster to the users. It's a great way to do it. Great concept. Note, by the way, that there are small edge locations, there's larger edge locations, and then there are actually edge locations inside the data centers. So inside the regions, there's also like edge caching. So just know you can cache really large material at the regional caches. So remember, we've got regional locations, which have availability zones inside of them. We've got local zones, which are just small, like single collection of data centers. And then we've got these edge locations, which are either servers or racks of servers, not a data center, that are just located at every major ISP. Actually, back in November, I had a guy, one of the installers for AWS was in my class. And he said everything you just said was actually accurate. He was kind of surprised because he's like, I thought that was supposed to be top secret. I was like, was it? Seemed like it was public knowledge. You guys always talk about it. Now, I mentioned before that the edge locations act as caching servers or DNS servers. So note that you could have a customer over in Japan, right, who might want to access your cat video over here in Brazil. So instead of them having to kind of like go over the internet and go down here, get the video, bring it back, and then come up here, instead what they do is DNS redirects them to a server that AWS owns, an edge location. That server runs over AWS's high-speed backbone, retrieves the file, brings the file back to the edge location, and then feeds the file back to the user. And the second, third, fourth, and whatever number of users after that who want that file can just go here to get the file instead of having to go all the way back to Brazil. That's what content delivery networks do for us, is they bring this content closer. Now, people say, well, Michael, what's the difference then between like this edge location pieces and say like a local zone? Well, here's the difference. Edge locations are only for caching static data. Local zones actually can host full-scale applications in major metropolitan areas. So edge locations are just for caching. Local zones are when you want to make sure that application is as close to the user as possible. So just know that the difference. Local zones are actually application hosting. Edge locations are just caching. Questions? Okay. Last little piece, and then we're going to roll into a lab. That's probably pretty much going to be our morning at that point in time. Okay. So we've talked a little bit about services and how to connect to services. We've talked about AWS's like global like networking infrastructure and hosting infrastructure, where the data centers are located and all that. Let's talk about the WAF, the well-architected framework. So the well-architected framework, and notice it has 6 pillars now. So sustainability has been added, was added to the last reInvent, right? So think of this as a framework to help you build secure, cost optimized, reliable, performantly efficient, operationally excellent, sustainable infrastructures in AWS. So it started as a white paper, and it's been expanded to include like domain specific focuses, hands-on labs, and the well-architected tool, which is a tool that will ask you questions so you can identify whether your workload is secure, resilient, that kind of thing, right? So the framework consists of security, cost optimization, reliability, performance efficiency, operational excellence, and sustainability. And with each of these comes very specific questions and sections that you can ask about your workload to make sure it fits these kind of 6 like cloud patterns, if you will. They have a white paper for each of these different sections. There's also a set of labs that will teach you about implementing these inside of AWS called wellarchitectedlabs.com. This is not in your workbook. Actually, you know what? I say that. They might have added it because I kept asking them to. Well-architected labs. These are free unlisted workshops that you can do on the different pillars and tools. And what this will do is this will walk you step by step through implementing like different security pieces. Like for example, there's a 100, a 200, and a 300 level. Let's say that you wanted to do some kind of Lambda cross account bucket policy. It will basically show you how to set up a cross account bucket policy. So it'll walk you through creating it. Creating the role. Could use some controls. Creating the bucket policy again. And then creating the bucket here. So just know that this contains security labs, operational excellence labs, labs on cost optimization, The sustainability portion is not really fleshed out fully. So there's only like a single 300 lab at this point in time. But just know that there will be more labs coming. The sustainability portion just got released 6 months ago, 7 months ago. And then last is the well-architected tool, which again, this link is inside your book, but it basically says, let me ask you a few questions about your workloads to determine whether or not you've adhered to the best practices for each pillar. So that they ask you stuff like that to kind of like, are you doing this correctly? Do you want to have someone evaluate a way to evaluate your workload to see if it's being used correctly? All right, let's do a quick knowledge check. Which of the following is the best example of one responsibility of an AWS architect? So just type in A, B, C, or D in your chat if you don't mind. Good. Analyze solutions for business needs. Sounds right to me. Monitoring alarms for disaster response. Sounds like more of an infrastructure role. Maintain application level code. Sounds like a developer code, maybe SRE if they're involved. Managing access to a group of AWS accounts. That could be infrastructure, security. There could be a couple of roles there. Which of the following is a cluster of data centers within a geographic location with low latency network interconnects between them? What is that called? A cluster of data centers. Good. I'm glad you picked up on it earlier. I was saying, look, a region is a cluster of clusters. It's not a cluster. It's a cluster of clusters. It's a meta cluster. So yeah, so technically availability zone is the cluster of data centers. The region is a collection of availability zones, which would make it a cluster of clusters, right? So people are always like, Michael, why do you, that's such a weird phrase. I know, but you all got that right. Okay, when picking a region, service availability isn't listed here and cost isn't listed here. What are the other two options that you want to think about, like most commonly thought out factors when picking an AWS region? Good. Primary benefit of deploying applications into multiple ACs is exactly as most of you stated, high availability for resources. Now, some people think, well, there'll be decreased latency. Even with a load balancer, by the way, it's still going to end up going to one or the other. So you're not going to see a decrease in latency. Unless the system's overloaded, and then you might actually see an increase in response time, which again, decreased latency might work there. That's not what they're asking. Okay. We didn't really talk about the principle of least privilege, but I'm sure most of you know what it is. The principle of least privilege is a principle under which well-architected framework pillar. If you want to make sure that you only give the user the minimum amount of privileges necessary to do the task at hand, what pillar do you think that might fall under? Good. Security, definitely. All right. Now know that with some of the future modules, we're going to do that review, and then we're going to do another review. Like we're going to do an even deeper review at that point in time. So, but this module is a little simpler, so we're just going to do this one as is. So our next task is actually to do lab 1. Now, just to say this, if we go out here and look, let's go take a look. There should be 12 labs out here pre-warmed and ready to go. What I want you to do is I want you to go ahead and log into webage.quicklabs.com if you haven't already done so. Make sure you open up My Learnings, click on Architecting on AWS, open up Lab 1, and once you open it, I want you all to go ahead and hit Start Lab. Give me a thumbs up once you've hit Start Lab in your thing. Good. Here's what we're going to do. So this is going to be set up for you. You're going to create an EC2 instance using the management console. You're going to do the same thing using the CLI. You're going to do the same thing using the CloudFormation template. And then there's an optional task where you can actually examine and run a second CloudFormation template. This is our focus for the next about hour or so. This lab, by the way, typically takes about half the time that's listed up here. But you've got an hour and 30 minutes, but usually it takes 45 minutes to complete. Now, am I going to hold you to that? No, it's your first lab. So just breathe, take your time. We'll be okay. But what I want you to do is I want you to hit Start Lab. And I think most of you have done this, so I'm going to go ahead and start mine as well. And what will happen is it will literally open up a bunch of information on the left-hand side. At this point, the main thing you want to do is, first of all, make sure that you are logged out of AWS. So see how I'm logged into AWS right here? I'm going to click Sign Out. I'm going to close these extra browser windows. And once I have signed out in this browser from AWS, I'm going to click on Open Console. And what it will typically do is sometimes it will actually log you in all by itself. Most of the time, you're going to actually end up copying the account number. So you're going to end up putting the account number up at the top. And you might have to put the password in there as well, right? Now, the username is always the same. It's AWS student. And then I'm going to sign in. I'm not going to save the password because it's just going to go away. Note that it should say North Virginia, and you should see an AWS student in the upper right-hand side. If you don't, switch North Virginia to North Virginia. You might say, Michael, how do you know that it needs to be in North Virginia? Well, let's go back to the instructions. US East 1 is North Virginia. Make sure you keep an eye on that console because it will change off of North Virginia to other regions. And if you put objects in those regions, they won't work. So make sure you stay in North Virginia. Notice that there's a subnet ID down here. There's some task template IDs. There's an optional template ID. There's the lab instance security group. There's all the information you need is on the left-hand side to complete this lab. The only other thing you need is directions. So there's us directions for starting the lab, which we already did. And then you're going to go to task 1, and you're just going to start doing what task 1 has asked you to do. Go to the search bar, search for EC2. Okay, that's cool. Let's go search for EC2. Cool, click on EC2. Caution, this lab is designed to use the new EC2 console. If a new experience is available, ensure that new experience is selected. Aha, okay. Am I using the new EC2 experience? Yes, I am. I'm good to go. And then you just start following the rest of it. For those of you who are not detail oriented, which I am not either, I get it. But if you put me in front of a code editor or we start doing these things, I become very detail oriented, because if you miss a step, it is going to wreck your lab experience. So if all of a sudden you get distracted and you don't remember what step you're on, go back a few steps just to make sure you're caught up, okay? Because if you miss a step, and this is true whether you were doing recipe driven or not, if you miss a step in AWS, it's not going to work. So make sure that you are very focused while you're doing these labs. And if you get distracted, go back and make sure your steps are good, okay? But that's it. That's all you have to do is you're going to follow the recipe. And when you do this, by the way, take a look around. Over here is the EC2 dashboard. Take a moment to maybe look at the global view, just as an example. But you're like, Michael, wait, this took me to a different place. I don't know how to get back. Well, you were just in EC2, so you can just type in EC2 up top. You can get back to EC2 at that point in time, okay? But feel free to take a look around, right? I want you to finish the labs, obviously, within 45 minutes. So if you want to finish the lab and then go take a look around, that might make a lot of sense. But just know that, this is your first time here, and no one is allowed to beat themselves up for asking me questions about where things are on this console. Because unless you've been in here 24/7 for the last 7 years, you have not seen this before. So just relax your eyes. They're going to ask you to find stuff. You're not going to know where it's at. Just go look for it. It's going to work out great. Okay. I'm here to answer any questions you might have. And you can take a break if you need to at any time. If you need to go take a couple minutes break. It is technically 11:47 Eastern time right now, 10:47 your time. Our lunch is scheduled about an hour and 13 minutes from now. This is probably all we're going to do this morning. So all I ask is that once you finish the lab, let me know that you're done. And then you can come back at, I guess that would be 1 o'clock Central, 2 o'clock Eastern. And then we're going to pick up the pace a little bit and go through the remaining 2 sections that we kind of ideally would cover today. Okay. Otherwise, that's it. We're working on lab 1. Any questions? Okay, let's get it. Got my chat window open. I'm still here. Let me know if anything comes up. Otherwise, let's go after lab 1 and just let me know as soon as you're done. Oh, by the way, let me know that you're done by clicking the reactions and click yes, like the green checkbox. So I know that you're finished. Okay. So we just talked about architecting fundamentals. So we covered, just a general overview of services, global infrastructure, how to access AWS, and of course, just the broad strokes of the 6 pillars of the well-architected framework, of which there's so much more to learn there. But just know that the bulk of your study is actually going to be around studying the pillars of the well-architected framework, because Amazon's going to ask you scenario-based questions about how to correct and improve designs against about 5 of the 6 pillars. They don't typically cover sustainability, but they will soon. So just know that 60% of the Solutions Architecture Associate certification is about either greenfield new designs or improving existing designs based on the pillars of the well-architected framework. So you've been warned. So here's a question that Amazon likes to ask in the course is, do you know how many accounts your organization uses? I gotta tell you, the only time I've ever known the answer to this question is when I was the global architect for Honeywell, and they had over 700 AWS accounts back in 2018. And I like Dave's answer is that really the answer is that they had too many, actually. So, because they were all relatively unmanaged. So, yeah, I love that 1 to 10 and 10. I don't know of any enterprise or medium-sized company that has less than 10 accounts. So C is likely the answer. But most of the time people say, I don't know, because no one has a consistently global view of all the accounts that are active typically, except for billing. So let's talk about the call to action here. So security is like, prototypes are great. We love that. But if we can't comply to security compliances, it's not going to help us. We use Active Directory internally. How can we federate that basically with Active Directory and implement some form of single sign-on? And then based on, how we're growing, our mock company expects to have 50 AWS accounts by the end of the year. How do we manage all those accounts? How do we keep them compliant? And then how do we do federation and single sign-on in the context of those 50 accounts? How does all that work? So a couple of very specific questions. What are the best practices to manage AWS accounts and resources? So how do you set permission boundaries, both deny boundaries and allow boundaries? And how do you do that at a micro level? And how do you do that at a macro level, like multi-account? How do I follow the principles of least privilege and only give out users access to resources, only the ones that they need? How do I give someone temporary access to a resource? And of course, how do I manage the whole thing in mass? Like, how do I manage like a massive organization? Massive, maybe from an AWS perspective, maybe small in other perspectives. So to tackle these questions, we're mainly going to talk about authorization and authentication. And then how does that lead to outcomes? How does that lead to access, basically? Authentication basically says, how do I verify you are who you say you are? And then once I know who you are, once I have an identity established, what are you allowed to do? What are you authorized to do? So just know that with AWS, there's only one service that governs the 99% of this, which is going to be IAM. Now, that being said, do know that while there are user-based services like IAM that control permissions, for some of the legacy services that existed before IAM was released in like 2010, 2011, do know that they actually have their own resource-based permissions, which can allow you to grant access to them outside of the identity-based permissions. So there's two types of policies in the environment. There's identity-based, and there's resource-based. AWS is trying to phase out the resource-based as much as possible, and they've done a good job of that for the most part. There's a few services that resource-based policies have lingered because, well, they're just heavily used. But most of what we're going to talk about is identity-based policies, meaning the permissions revolve around the identity versus you have to go to the resource, which authenticates your identity, which then grants you authorization. So everything being attached to the service versus being attached to the user, as an example. Notice here, by the way, that once the user is authenticated, they are then granted authorization, typically through a policy that's attached to their group. We typically do not attach policies to users. Policies are these permissions documents that either allow or deny access. Typically, if someone is part of a group, that's what grants permissions. Permissions are cumulative, and explicit denies override everything. So if someone is told in any of the different groups that they're part of that they cannot do something, that deny overrides everything else. It's called an explicit deny. Otherwise, if you do not grant anybody permissions to anything, they are implicitly denied access to everything. So by default, a user can do nothing inside the environment. They must be given permissions. And once they have permissions, if someone is explicitly said, Michael Forrester is not allowed to touch EC2, no amount of allows will ever allow Michael Forrester to touch EC2. So explicit denies always trump explicit allows. Now, once I'm authenticated and I'm authorized and I figured out what I can do, you may also need to elevate your permissions, much like we do with Linux. If you're like in Linux and you're like, you want to edit a file in Etsy, you're going to have to sudo that file. Sudo allows you to temporarily elevate your permissions and you can run it before the command, or you can even use sudo to actually take on another identity. Well, as you can see in the bottom where the hard hat is, where it says roles, Amazon has that same concept where, you know, in my demo account, I'm Emma Forrester. If I need to make changes, I actually have to assume a role called M Forrester admin. Let's take a look at this just to make sure that concept of roles is cemented in our brains. Now, first of all, let's make sure I'm signed out because that could get ugly. All right, so let's say I'm going to log back into my account. I do have MFA enabled, so it should ask me every single time. All right, so here I am logged in, and notice it says Spartan Sage and M Forrester. That's the nickname my son has for me, Spartan Sage. M Forrester is my account name. So let's say I need to actually do something in my account. What I can do is I can actually do what's called switch role. But I'm going to copy my account ID first. I'm going to switch role. And then from here, this is the account, which is the same account that I'm actually in currently. It could be a different account though. And I'm going to switch over to M Forrester admin. Not going to change the name, but I am going to change the color. Switch roles. What happens in the upper right-hand side? Notice that first of all, my username is switched from Spartan Sage to M Forrester admin. And now my account number is showing because I didn't put an alias in there. I just said, let me put the account number in there. So it highlights that I am now have assumed a set of security permissions called a role. So I'm still M Forrester in terms of my identity, but the role has now authorized me to basically have this other set of permissions. I do want to point out that the role has permissions for who can assume its identity. So not just anybody can become M Forrester admin, only Spartan Sage can become M Forrester admin. So just know that roles have their own kind of assumptive permissions that you can assign and restrict them with. But also just know that anybody who has the like assume role kind of function could assume the role if there's no restriction set on the role. So you want to make sure there's conditions set on the role when possible. So here I am assuming a different role. If I was done, by the way, doing whatever manipulation, I can just switch back. And now I'm back to Spartan Sage, which is just my normal user. And if we look inside IAM, which is where all this magic happens, IAM is the Identity Access Management Service. In here is where I can find the roles, right, for M Forrester. So if I come in here and look at roles on the left-hand side and type in M Forrester, there's M Forrester admin with all of its resultant permissions, which in this case is administrator access. Notice that I have lifted the trust relationship to basically allow anybody to assume the role, because I remember that was something I did recently to do some testing. But typically it would have a condition where a user is equal to Spartan Sage, right? Saying, look, the only person who can assume this role is basically Spartan Sage. So the user is Spartan Sage. I'm actually part of the administrators group, and my role there that I assumed was M Forrester-admin. So it allows me to basically to put these three principles together. All three of these, by the way, can be assigned permissions. So a role gets permissions through a policy. Users can be actually assigned permissions. Typically best practice is to assign permissions to a group, not directly to the user. The main reason for that also is that if the group names are intuitively named, you can figure out someone's permissions without having to go through and parse all the JSON involved. Amazon does have a bunch of tools like Access Analyzer and whatnot that will help you figure out all the permissions that have been assigned to a particular user. But, you know, just be aware that it is easier if the groups are intuitively named with their permissions, like project A, bucket B, full access. project A, bucket C, read only, that kind of thing. Now, getting into the module, we're going to talk about the 3 principles. We're going to talk about policies. We're going to skim federation, and we're going to talk about how you can manage multiple accounts, because those were our original questions here. Those were our objectives. Elias, so it's close to a RBAC model. Yes, it is. Especially if you're like thinking like Kubernetes, it's very similar.
Yeah, thank you. Just like it's different that with RBAC, only we can assign the permission to the rule. We cannot assign directly the permission to the user. This is the only
Exactly.
difference, I guess.
Yeah, because the entity has to be bound to the role, right? And then that's how they get permissions.
Yeah, correct.
Yeah.
Makes sense. Yeah.
And that's why I say it's similar, because obviously you can't actually put users in groups inside of IAM.
Yeah, interesting to know. Thank you.
One question I frequently get is that, can you put groups inside of groups? No, and you can't put roles inside of groups either. So unlike Active Directory, for example, where you can stick groups inside of groups, you can't do that inside of AWS. I don't know why. All right, couple of things to note. If you go to log into your AWS account and you're using an email address as your username, you're logging in as what's known as the root user. The root user is the user that is created when you create an AWS account. I want to say for accounts that were created after, I want to say December 2019. One of these Decembers, it was either 2018 or 2019. You couldn't restrict the root user from anything. Starting, I think it's December 2019. No, my dates could be off on that. You can actually restrict permissions for the root user using organizations and what they call service control policies. You couldn't do that prior to a certain date. They wouldn't, it wouldn't support it. As a general rule of thumb, I've seen one business go out of business because they misused the root user and somebody got a hold of it and deleted the entire non-production environment. So as a general rule of thumb, don't use the root user for anything. Don't create access keys. Don't create secret access keys. Do not use it to create your first IAM administrator, and then randomize the password, assign MFA, and then put it away. Don't use it. Only use it in case of emergencies. So you don't want to use this for day-to-day interaction. This should go away. Now, once you've created your first user and you've given that user admin privileges to create other users, then your journey kind of starts, right? And this is where the authentication, like, how do I verify who you are? And then what are you allowed to do for authorization? This is where this comes in. Now, IAM is the primary service that provides all of these principles and functions and federation and integrations and all that. So you'll find pretty much anything to do with managing AWS resources is going to happen through IAM. The principles are groups, users, and roles. Sometimes services are counted as a principle. And I will tell you, like, they keep putting this on the slide and it's really just not true. Identity providers or federated users are really not principles. And let me tell you why. Identity providers are separate systems that AWS trusts to provide authentication. But in order to authorize, that user actually has to be associated or tied with a role. I know that sounds strange, but this federated user must have a role before it will actually be granted access to AWS. So users, like inside of an Active Directory federated system, actually have to be associated typically with a role before they can actually get permissions. And those permissions are associated with the role here. So it always bewilders me as to why they include this as an entity, because it's really not. It's users, roles, groups, and services sometimes can be entities, because you can actually assign a role to a service as well. What does that mean? If you're running an EC2 instance down here and you want it to have access to DynamoDB and S3, you can actually assign a role to the EC2 instance, and it can assume the permissions necessary for that application to talk to DynamoDB and S3 based on whatever way you specify. So just know that Lambda functions do this, EC2 does this, ECS tasks and EKS like pods can do this as well. The containers inside the pods can do it. Like they can assume permissions. So just
the use of service accounts.
say again.
Would that be like service accounts tied to the resource?
It can be, but actually what's happening is that AWS doesn't actually need an account because AWS knows what that entity is because it's tied to your account, if that makes any sense. In other words, every time you start a service inside of AWS, it already has an identity for that service because it's already under the fingerprint of your account. So service accounts are typically used for external entities. Like if you have somebody coming off premise, coming into your into your AWS account, you want to have a way to receive that linkage, and that usually links to a service account because AWS has no way of identifying, has no way of authenticating that entity unless you tell it what it is. So service accounts are usually used to federate with external systems. Like Kubernetes is also registered typically via a service account into AWS because AWS has no way of authenticating who that Kubernetes system is except from the relationship that you define. Does that make any sense? So it doesn't need that for services because it knows what the services are. It knows that the services are on your account. It knows they're running on AWS infrastructure, and it has a unique fingerprint for every service you run. So it only really needs service accounts for external entities.
Oh, okay, I see. Yeah, I'm actually coming from a GCP environment, so I guess the usage there is a bit different.
Yeah, it's a bit different. Is that what's usually confusingly called an instance profile? Yes, Rakesh, for EC2. Yeah, so it's an EC2 instance, and so they attach a profile to the instance. It's sometimes referred to as an instance role as well. I don't know why. I don't have an answer for why they named it that way, but it is confusing. So services, including service accounts, by the way, so we'll throw that in there, Kyle, so thank you for mentioning that. Roles, users, and groups are all, for the most part, the 4 principles that you're going to find. They're not going to test you, by the way, on identity providers or federated users as principles. Just know that in order for IDPs to work, there needs to be a trust relationship between the IDP and the AWS account. In order for federated users to work, there needs to be that trust relationship and a role for the federated user as well. So it's a multi-step process. Now, beyond principles, beyond principles, including principles. So we already talked about users, so this is actually pretty clear. Users are assigned permissions that allow them access to certain resources or services inside of AWS. This is not for application users. This is not for website users. This is not for mobile users. This is literally to just grant permissions to AWS resources. That's it. Now, users ideally are one-to-one. So I only have, I could have many users, but like I'm responsible for the account. I'm the only one. It's not like me, Elias, Chris, and Kyle would all share the same account with the same username and password. There's no accountability then. That doesn't work, actually. So typically, at least there's usually one owner, and it could be many accounts, but there's one owner for the account. You may say, why would the person have many accounts? Maybe the person has multiple applications, multiple devices. It just depends on the organization's policy. Now that user is going to use the access keys and secret access keys to access the CLI and the SDK. And if they've been given access to the console, they'll use a username and password, just like you saw me use earlier. Here, by the way, you can obviously inside the permissions, the policy document, you can specify a very explicit level of granularity about what you want someone to be able to do. If you want them to do anything, just put a star for every single API call behind EC2 or S3 or DynamoDB or Systems Manager or whatever. if you want them to only be able to do specific calls, you can actually list those out one at a time, right? And just say, look, I only want them to be able to read. They can only describe, list, and get. They can't update, they can't delete, they can't change, they can't modify. So you get to control down to a very granular level what you do with the policies. So to rehash, the root user is not for daily operations. So you're not going to use the root user. Sorry. The IAM username and password is typically used to access the console. The IAM access keys and secret access keys are also used to access CLI and through the APIs. And then MFA is just that extra level of security you can turn on for all of this to require it to be something that you have and something that you know. Although I would argue the access key and secret access key means something that you have and something that you have. So yeah. Note here that this access key and secret access key, when I ran AWS configure earlier, when you saw me messing around with the command line, there was an option to enter in the access key, the secret access key, then the region and the output. I don't know why they don't list the secret access key here, but it should. So it usually does actually list the secret access key. Once you create the access key, like the secret access keys, if you do not download it when AWS presents it to you, you'll never see it again. You can't recreate it. You have to delete it and generate a new access key, secret access key pair. Okay. The other thing to know is that AWS is not going to log you into your EC2 instances. So unless you've enabled Systems Manager, which is a separate service, typically you're going to use what's known as EC2 key pairs to log into your system, which I think most of you saw like proceed without a key pair when you were doing the lab just now. So just think of the key pair as a lock and a key. Every single box you create with the key pair gets the lock and you have the key. So when you SSH or RDP into the system, you have to provide the key in order to open the lock. So think of the lock as the public part of the key and think of you having the key as being the private part of the key. It's a little different than what you're seeing here with the access keys and the secret access keys. So don't get this confused because this is only for API access to AWS. You need an EC2 key pair in order to log into the operating system of an EC2 box. Now groups, we probably visited this pretty strongly already, and it's probably intuitive to most of you, but it's really just a place for you to collect users and then assign permissions to those groups. So obviously users can be members of one group. Just a reminder, you cannot nest groups, so you can't stick groups inside of groups in AWS. Roles we talked about before. These are security identities or security permissions that you can assume for a temporary amount of time. If Amazon asks you a question that says, I want to give temporary access, if they say the words temporary access, temporary access, temporary access, how many times is Michael going to say that? They're talking about roles. That's just the way Amazon thinks about it. Whenever they say the words temporary access, they're assuming you're going to give them a role. Now that role might be used for 3 or 4 years. Still considered temporary access by them. So users are ways of granting permanent access. Roles are ways of granting temporary access. Now, there's this service that sits underneath IAM called AWS STS. This is the security token service. The secure token service is really interesting because if there's a trusted entity like IAM or an AWS service, and by the way, why would it trust an AWS service? Because it knows all the services. But if there's a trusted entity on the left-hand side, it can assume a role by talking to STS and saying, hey, I want to assume the Forrester admin role. STS will grant a token representing that role's permissions, and that token will temporarily take over the permissions of the end user. And then you can use that token to go talk to the EC2 or DynamoDB or whatever it is. So just know step one is you assume the role. Step two, STS sends a temporary token to you. And that token, by the way, has an expiration timer on it. And then step three is that you as the entity use that token to talk to AWS with those elevated set of permissions. Now, notice that policies can be assigned to any of the three core entities. Policies cannot be assigned to service accounts or services, sorry, because that happens through roles. So roles are when how the policies get attached to other service entities. Notice here that the resource, if you see the word resources, by the way, think also service, but like one of the services is now assuming the permissions of the role. A user is assuming permissions of the role. So again, it kind of highlights that roles are like limited pseudo access. So just remember that. By the way, roles can be used for cross-account access. So if I have a role in account B and I'm a user in account A, I can actually assume the role in account B and take over permissions over there. You might say, why would I do that? Well, imagine you're in security. Maybe you are actually. Imagine you're in security and you have to audit 500 accounts, which actually happened for one of my security team members. Had to manually audit 500 accounts. Instead of creating 500 different, and they could be the same, but like 500 distinct username and passwords for each of the 500 accounts, we gave him one username and password, and we created roles in 499 other accounts. And all he had to do was to assume the role in the account, and then he had permissions to do all the security auditing he needed to. And then he got out of the role, went to another role in order to do all the security auditing. That way he only had to manage and remember one username and password. So be aware that roles are really only necessary. Are not only necessary, but are really great to use when you have many accounts to manage. Use roles to manage those accounts. Don't create a user for every single one of your accounts, especially if you're in the hundreds or even dozens at that point. It's wasteful. It is also worth mentioning that you can federate with anything that supports OIDC and SAML, so SAML 2.0, right? So anything that will support the latest versions of either SAML or OIDC is going to work great as a federated entity. That includes Ping, Federated, Okta, whatever you're using. ForgeRock, although ForgeRock is more application side, but you can still do that if you want to. Note that Amazon does actually have a user store for mobile and web applications. It's called Cognito, COGNITO. So this is not what AWS IAM is for, but AWS Cognito is totally for mobile and web users. And it will actually federate itself with IAM as well. So if you need a user store for your application, look at Cognito. Don't use IAM for this. I didn't even know that did that actually. I just hit the plus sign on accident on my my keyboard. Learn something new. All right, so let's talk about security policies next, because this just dovetails nicely with entities here. So we got users, groups, and roles, plus we've got services, basically. Now here's where things get weird. I mentioned that there were identity-based policies, and I mentioned that there were resource-based policies. Resources-based policies are attached to the service. They evaluate who you are and what you can do at the service level. Identity-based policies are where the permissions are attached to the user or group or role. And once you authenticate, you are granted permissions based on what's in the document. So same idea, but instead of the user going to the service and having the service say, oh yeah, that user can talk to me, the user already has permissions to talk to the service and they just go talk to the service. So it doesn't need to check with the service to see if this can happen. This is all on the grant permission side of things. And this is all at an account level. This is all IAM. Just want you to note that. It's all IAM. In addition, this box right here ideally should be moved right here. So this should actually go away. But that should, the permissions boundaries should actually be moved right there in the middle, because permission boundaries sit inside of an IAM account, not at the organization's level. And it basically defines what a person can and cannot do. It provides a delegated block list. So like if you want to create admins inside your IAM account, but you don't want them to have access to everything, you can block off services using these permission boundaries that are listed here. Now, notice that that's an IAM function. It says IAM right here. So this is IAM, this is IAM. So this is all at a single account level. If you want to set maximum permissions, but you don't want to do it at a single account level, like it says here, you want to do it for an entire set of accounts. You want to do it for 500, 700, 600, 1,000, a million accounts that you have in AWS, then you're going to have to use AWS organizations and you're going to have to use what's called service control policies. These policies do not actually like grant access. They allow you the permission to grant access. But if someone comes in here and says, look, we have no reason to ever use quantum computing, and they come in here and they create an SCP that says no one can ever use quantum computing in the entire organization, no amount of permission boundaries at the IAM level will allow that to happen. You have to remove the SCP negative first before you can get to any of the grant positives on any other station. Does that make sense? Does that not make sense to anybody? So the hierarchy, this is top, this is king, then this is king. And then just to say this is that these two are kind of both next in line. Whoever, by the way, has the most restrictive policy wins. So most restrictive always wins. I want to make sure this dividing line is really clear. IAM is the only one at the account level that can grant permissions. IAM permission boundaries and AWS SCPs can only deny people the ability to grant permissions. They do not grant access. So as an example, even though I'm blocked at quantum computing at this level, and I want access to the robotics section, someone has to come over here and give me access to the robotics section in the account, even though I am not being blocked from access over here. So I want to make sure that's super clear, is that IAM is the one who grants permissions, and that must happen every single time. The only thing that this layer over here can do is deny you the ability to give permissions. That's all it can do. I'm assuming that you're all getting that. We'll find out. So granting permissions, right? And then the denying of permissions, which is what the left-hand side is. So defense in depth, just to make sure we're clear about how these permissions work, usually uses a combination of identity-based permissions and resource-based permissions. Just know, remember what I said, AWS is trying to get away from resource-based permissions, but they're still at play for some services. So for example, here, you've got a user who assumes the role that gives them permissions to go forward. And then as they try to access an S3 VPC endpoint, that has a policy attached to it. As they try to access the bucket, that has a policy attached to it. And as they access the key for the KMS key management system, that has a policy attached to it. Thus, eventually you'll get there. But notice that the grant was here, 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 or here, all for different parts of the service. So notice that there are a couple of identity-based policies here, right? So some are based on role, some are based on service access. You can also create your own custom policies. Just note that if it's an AWS managed policy, because out of the gate, just so you know, AWS gives you a bunch of policies you can use, which by the way, almost no enterprise I know sticks with these policies because they don't want AWS to have control over them. Almost everybody writes their own custom manager policies that are managed by the customer, right? Just know that the AWS managed policies cannot be edited by the customer. So they cannot be edited by you. So if we come in here, just to show you this, and I want to go take a look at policies, notice that there's a bunch of customer managed policies that I've written over time. And then trying to think of where that might be. Here's some AWS managed policies: Cloud-wide agent, OpsWorks, configuration manager, instance profile role. Here's read-only access. Instead of view, they call it view-only instead. These are all AWS managed, meaning that these were all done by AWS. If they're updated, they're going to be updated by AWS. So you can't edit these in any way, shape, or form. Now, could I steal this JSON? Absolutely, I could steal this JSON. But in general, most people avoid making their own policies if AWS has already created one. Now, a policy has a few elements to it. Let's go see if we can find one that might be fun to look at. Here, by the way, is an assume role action granted to this CloudFormation so that it can actually take on the AWS Tower execution role. Obviously, the effect of it was allow. If it was a deny, it would obviously block it off. Really straightforward and simple. Let's go take a look at another one. That's an EBS CSI driver for Kubernetes. I don't know that I've even actually ever looked at that one. Okay, this one actually might not be that bad. So notice that first of all, there's an effect. What's the effect? It's either allow or deny. That's it. Those are the two effects. Then there's an action. In this case, it's allowing whatever this is attached to attach a volume, create a snapshot, create tags, create volumes, et cetera, 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 and so on forth. Okay. And then what resources? It's basically saying any resources. You could also add things like conditionals in here. You could put a condition in here that says, hey, if it's between March 1st and June 1st, it's okay. If it's coming from corporate IP address 5.5.9.6, sounds great. We'll support it. So just know you can also put another section in here called conditionals. Now, in a resource-based policy, so this is an identity-based policy. In a resource-based policy, you might also have, instead of an action, you might have a principle, which could say user ID equals Spartan Sage. Why do I not need to define the principle in an identity-based policy? Who's the principal in an identity-based policy? Give me an example. Let's say we're at Spartan Sage right here. How come if I go, for example, look at EC2 full access, how come I don't need to specify a principal in here?
Because it's you.
Connor, you're down the right road. How do I know? How does the policy know it's me? In other words, what's the linkage between me as a user and the policy?
Well, the policy gets applied either to a role or to a group. And if you, the user, fall under that group, then you automatically assume the policy. Or if you, the user, assume the role, then you get that policy.
That's exactly right, Rakesh. So if the policy is attached to another entity like a role or a group, and then someone either assumes the role or puts me into the group, that's the linkage. I don't have to declare a principal because I'm in the group or the or the object that the policy is attached to. That's why it's an identity-based policy. It's attached to my identity, either indirectly or directly, right? So that's why it's an identity-based policy, because it's attached to me. Now, it might be attached indirectly. I might be part of a group and it's attached to the group, but by proxy, I'm in the group, it's attached to the group, I get those permissions. That's an identity-based policy. That's different than a service or a resource-based policy, which says the policy is attached to the service. And so the service is the one that has to do all the identification and all the other assimilation. Identity-based policies, the policy knows who it's talking to because there's linkage, there's a relationship defined there, right? The onus for doing that for a service-based policy or a resource-based policy is on the service, which that's why Amazon moved away from this whole thing, because service-based policies are a pain in the rear end. They're a little harder for environments that AWS may. It's easy for AWS when it controls the entire environment, but then how do you authorize external entities? It's a little harder at that point in time. Notice, by the way, that there's the effect condition here for this particular section of the policy. There's an action, which basically says, I want you to create a service linked role. There's a resource, which really just doesn't have any limits. It just says any resource. But notice the conditions. I will allow you to execute a service linked role, to create a service linked role, if you are either auto scaling, EC2 scheduler, the load balancer, spot fleet, or a transit gateway. Everyone following that condition? Yeah, David, sorry, I missed your comment. Yeah, you were exactly right there too as well. Everybody understand that this condition basically says, look, if you're one of these services, then you get this permission. If you're not one of those services, you don't get that permission.
Yeah, that makes sense.
Good. Good, because that was this entire slide right here. Effects, allow or deny. Principal, which is only used for resource-based policies. You don't need it for identity-based policies. And then actions and resources, which are required. Conditions are not required, by the way. And by the way, there are so many possible conditions you can apply to IAM. Like, it's like regex. It's like regular expressions. It's like this magic. Like, it's crazy what you can end up doing. Date-driven, string attachment, service identification, from IP address, with this combination, it's like, it's amazing what people have done as conditions inside their IAM policies to, meet their corporate standards. So Elias, that's what I mean earlier when you said, usually we need a principal when we do identity management with an external user. Remember I said earlier that in order for a federation like this to work, let me go back to my original slide. Where was that thing? See where it says identity provider down here? In order for that to work, the identity provider has to have a trust relationship with AWS, and the federated user has to have a role. So the policy is attached to the role, and the federated user goes and gets the role association. So someone has to actually associate the IDP and the federated user, or usually the federated groups, with a role. So you have to put the linkages together there.
And for that to work, the role needs to explicitly trust that user, right? Is that how that works?
Not really. What happens is that because there's a trust relationship between the AWS IAM and between the identity provider, it explicitly trusts the identity provider. But then what happens is that you're explicitly attaching the role either to the group or to the user. So there's an explicit relationship that has to be declared there.
Oh, gotcha.
So it doesn't have to trust it because that's an authentication problem, right? And that's already happened, but because the AWS account and the identity provider are already linked together, they already trust each other.
Right.
once two authenticating bodies trust each other, and assuming there's no filters there, they will trust each other's authenticating capability. So then all you have to do then is solve authorization. And that gets solved by associating a role with either a federated user or a federated group, to be clear. Could be
But
a
what
federated.
if I'm trying to assume a role in a different AWS account? What happens then?
Then that account also needs to trust the identity provider.
Trust, got it, yeah.
Or if the role in the other account will allow you from this account to access it,
Yeah,
then you can use the AWS account that you're in to assume the role in the other account.
got it.
So it doesn't necessarily just have to have a trust relationship with the IDP. You could actually just trust one AWS account and have all the other AWS accounts trust that one that you federated with.
Right.
Yeah. Single sign-on, by the way, works that way. So if you ever use the single sign-on service with AWS, they all trust one AWS account that is the single sign-on account. So it works the same way as you were hinting at, Rakesh. Elias, did I answer your question?
It's perfect.
Okay.
Thank you.
You're welcome. Perfect seems like high praise, but as long as I answered your question, we're good. Okay. So remember, you need an effect, an action, and a resource for the policy to take effect. Principles only exist with resource-based policies, and conditions are optional. So notice here, even though you may not have ever written an IAM policy, you know what this does. First of all, it allows something to happen. There's two services involved. Notice there's an asterisk there. And then the resources are very explicit. So it is explicitly this DynamoDB table and explicitly the bucket and the contents inside the bucket. Now, if someone comes along and does this, which I've seen on occasion, this, by the way, is going to say, look, if someone tries to access any resource other than these resources, they're going to get denied, because notice it says not resource now. Now, AWS throws this around as an example. I've never seen an enterprise do this because it's really a pain to troubleshoot, right? But somebody must be doing it. Otherwise, they wouldn't keep throwing it around as an example, where you basically have an allow policy and then you have a deny policy that says, well, they can access anything but this. Just to say this, you are implicitly denied every access to everything. So this is a little bit of overkill, but it's a good example of an explicit deny. We've mentioned conditions before. So notice the effect is allow, the action is start, stop. The resource is basically any EC2 instance. Notice it says that you can stop or start any instance where the owner is equal to your AWS username. In other words, if you're the owner, you can stop it and start it. Otherwise, you're going to be denied. So question for you, are conditions required or are they optional?
I believe they're optional.
They're optional. What are my two possible actions for effect?
Allow and deny.
Allow and deny. Good. And then just to say this, for actions and resources, the only limit is how you want to denote all the resources and API calls inside of AWS. So there's no limit to the number of actions and or resources you can list in a single file. Okay, what this chart basically tells you is that if someone is explicitly denied, in other words, someone has come in and said, you know what? You're not allowed to do anything. Well, guess what? They can never do anything. An explicit deny has to be removed before they are allowed to do anything related to the service that's being blocked. But what if there's no grant permissions? Well, if there's no grant permissions, guess what? They're still denied. So even if no one has said no, it's implied the answer is no. Feels very like quasi-parental somewhere. But just to say this is if no one has said no, but someone has said yes, you are allowed to do the thing, then you are allowed to do the thing. But just know that if at any point in time someone comes in and says, so you know what? No, you can't even touch EC2, then you're going to get denied, and that's going to be the policy. So remember, explicit denies trump explicit allows, and explicit allows trump invisible or implicit denies. Okay. Here's an example of a resource-based policy. What's the difference? The only difference is the inclusion of this principle. In this case, it looks like basically they added this entire AWS account. Good job. Right? They didn't actually specify a user. They was like, hey, all of AWS, this entire account. I will tell you that resource-based policies are still used for S3, SNS, SQS. Those are by the way the services that predate IAM. Let's say OpsWorks still has it. I don't know why OpsWorks does. I thought OpsWorks came after, but regardless, OpsWorks has it as well. I think those are the only ones left, actually. Oh, KMS. I just looked at my speaker notes. KMS is the other one that has it. There is an access advisor. Access advisor, it's a tab inside the console. It will let you see the aggregate information of like who's accessed what and what permissions are being granted through what. So you can actually see user permissions. It's not a great en-masse analyzer. There are other, like I know of them. There's like third-party tools that will go in and analyze all your S3 permission. I'm sorry, your AWS permissions. This can get really cumbersome at scale. So haven't really seen a good solution for this yet. And I say this because the way most people approach AWS is that they put everything inside of an organization, and each team will get one or more project accounts. And one of those accounts, it might be production. One of those accounts might be like non-production. And what will happen is that all billing for those accounts are billed against the project code for the project in question. And so that way, by doing a per account kind of project delineation, you don't have to sit there and worry about making sure that everything's like hyper tagged, because everything in that account belongs to the project. So if a team's over there blowing $20,000 a month and they can't justify why, it's still on them because nobody else has access to the account. So people have gotten around this, like having like 10,000 users have, permissions into accounts by only allowing them access and by doing a per account per project kind of setup. So they only allow them to have access to those accounts. So you won't find users unless they're, like an Uber admin. You won't find users with access to more than like 10 projects worth of accounts. So then that access doesn't get super weird and complicated at that point in time. You just need to make sure that Bill, who may have left 2 months ago from Team A, doesn't still have access to Team A's stuff, that kind of thing. You can get around that, by the way, by putting expiration conditions on your policies. So, or putting expirations on your users. So this is the access advisor. This is the IAM access analyzer. This is very different. So this one tells you about identity-based policies and what those permissions, who's been accessing them, what they look like. The IAM access analyzer is going to tell you who has what external accounts have access to your resources. So it's going to tell you who has permissions to your external resources inside your account. That can be useful from an audit perspective, particularly. Notice here that Cognito several times is a service that was federating in who had access to the account. And then we talked about permission boundaries a little bit, where permission boundaries, unlike IAM, which grants permissions, a permission boundary is used to basically like deny someone who has a big set of permissions access to the full like scope of those permissions. Does that sound dumb? It did to me. And I had a long conversation with AWS. I was like, why did you do this? Why wouldn't you just create specific permissions that prevented them from having access to, you know, the things in question? Like, why would you grant them access to everything and then scope them down? And they were like, some people didn't want to take the time to weed out, you know, 200 services when they only wanted to grant 5. Or sorry, didn't want to weed out, you know, they wanted to grant access to 200 services and they wanted to weed out 5. And so they, you know, Amazon built this feature so that you could say, look, this guy's an admin, but he can't touch quantum computing, he can't touch satellites, and he can't touch the lumberyard. Great. So think of permission boundaries as a way of you giving someone a broad set of permissions and then chopping off a few that you don't want them to have access to. You know, again, there's other ways to solve this challenge, but that's the reasoning they came up with for why they generated this service. Now, identity-based policies are what we've been talking about. The permissions boundary, all of this operates at an account level. So this is not multi-account. But when we get to organizations, particularly when we use SCPs or what's called service control policies, that is an account, like that's an organization-wide policy that says anybody who falls under the auspices of this SCP cannot do the thing in question. So we'll get to SPCs later in this module. We're going to talk about federation first, but just know that they figure heavily as a way to manage an enterprise's access to a service. Okay. I was like looking at the time. I was like, huh, it's been an hour. I'm going to talk about this and then we're going to take a break. These last 2 little sets. Okay, so we talked about the security principles, which includes users, groups, roles, and then service counts. We talked about the policies, which, you know, there is the blatant identity policy, there's the resource-based policies, and then we've got permission boundaries, and then we've got SCPs, which we haven't really talked about SCPs yet, but we'll get back to them. We did talk loosely about federation because it's like we've got Active Directory accounts. Why would I recreate all these users over in AWS? Well, you don't. You don't have to do that. What you can do is that, you know, without some kind of linkage, Active Directory groups are not related at all to AWS permissions, right? So users are like forced to authenticate against Active Directory, and then maybe they're forced to authenticate against like Salesforce, and then they're forced to authenticate against AWS. It gets crazy. Single sign-on is really what you know the user experience really calls for. Plus, just to say this, the more passwords you give a user on different expiration timers and whatnot, the one, more likely they are to forget it, which causes overhead. And 2, the more likely they are to cheat to remember it. You know, what is that security? Oh God, not compliance, but there's a word for it where it's like what they will accept from a security perspective before they just start to rebel, right? They start putting stickies all over the place and doing all kinds of weird stuff. So Amazon will allow you, like without, if you don't have single sign-on, like this is the world we live in, right? If you decide that you want to federate or, you know, create single sign-on, what happens is that these federated users that you can see over here on the corporate side, they don't have any AWS accounts. They do not exist on AWS. So what happens is that you're going to have to take these non-AWS users who live over here, and they're going to have to be given some set of permissions over on the AWS side of things. What happens is that the roles, which we were talking about earlier, that exist over on the AWS side of things, these need to be somehow assigned to these users. So how does that happen? Well, what happens is that the identity provider is basically through this SAML 2.0 or open OIDC, OpenID Connect, there's a trust relationship created. That takes care of authentication. At this point, we trust that these users are who they are, right? So then what happens is that then, particularly if there are groups inside this identity provider, they can all en masse be assigned to the same role, or by group, they could be assigned to different roles as necessary that give them access to AWS credentialing. Now, when you first do this, it's a little tedious, but once it's done, all that happens is users get added to groups on this side of the equation on the identity store, and you don't have to worry unless you decide to change permissions or create a new project or whatever. And then you probably created a new group on the left-hand side. It all works out, right? There's just some coordination there. So I don't know if there's anything else to say there. Just checking my thoughts and then looking at my notes. So single sign-on, which by the way is kind of an undersold piece of software that Amazon has pretty much for free, right? It helps you basically not only do federation between AWS and between like your Active Directory, but you can do third-party software as well. Like any of the software SaaS services that support OIDC or SAML that will federate in, we'll use AWS as a centralized portal for this, right? So then what happens is that single sign-on becomes a user portal where your users can find and access all of their AWS accounts, all of their cloud applications, all of their SaaS providers, all in one place, right? Now, you could also, by the way, federate this with Okta or, well, Okta, they've fallen out of favor, haven't they? Ping federated, right? Azure AD can also hook in there as well. Notice it says Salesforce, Box, Office 365, and others. So this is going to allow you to give single sign-on, use your existing identities. It, just create coexistence and compatibility for sign-on across all your environments. People rave about this service because one, it's free, and two, it works really well. Last but not least, how do we manage a bunch of accounts, a bunch of IAM AWS accounts at scale? How do we do that? Well, there's three components to this. One, most people are going to follow a multi-account strategy. It's going to be an account per project. They don't have to worry about billing at that point in time. Anything that's in that account goes billed against the project in question. You get isolation, clean business processes, clean security controls if you apply your security policies in an automated fashion. And so a multi-account strategy is typically the way people go. Now, without organizations, you are going to have to set up security policies for every individual account, and you must enforce them through each individual account. So a bunch of stuff is going to end up being duplicated. If you put them in an organization, what happens is that when you apply an SCP, say to an OU, or let's say it's this OU instead, every single one of these accounts that's inside the organizational unit, that policy is going to be forced on. And so these service control policies can set it so you can restrict people's ability to do stuff. This is how this works. If the organization has an SCP that says, hey, you're allowed to use EC2 and S3, and there's an identity-based permission set that says you're allowed to use EC2 and SQS, then EC2 is allowed. Notice it didn't say it was allowing S3 over here. So nobody's allowed to use S3, even though the SCP says you can. The identity-based policy doesn't grant permissions. The SCP does not grant permissions. The identity-based policy is the only one that grants permissions, but only if the SCP allows it. So think of SCPs as a filter. If the filter is not there, then the identity-based permissions go forward. If the filter is there, then the identity-based permissions must get through the filter. If the filters don't match, then nothing happens. Any questions, any confusion, any clarity needed about this particular thing right here? Okay. Here's an SCP example, by the way. For example, you can have an SCP that says, look, everybody can get access to EC2, but only for these like 5 regions or this one region or whatever. So you can actually put conditions in your SCP that says, look, nobody better be in Shanghai. Nobody gets to be in Hong Kong, right? You want to be in Mumbai, you want to be in Hyderabad, you want to be in Ohio, you want to be in Sao Paulo, you want to be in Frankfurt, that's fine. But you don't get to be in, China, right? For whatever reason. I'm not singling them out. I'm just saying, like, maybe that was the country, right? Maybe it was Jakarta. You don't get Jakarta either. So just know that your SCPs can also have exclusion conditions inside of them. So just like identity-based policies, you can put conditions in there. Now, if organizations with SCPs are used to control multiple accounts, just know that Amazon has a pre-canned multi-account enterprise setup environment called the control tower. And it actually is off of an older product called Landing Zone. And what it does is it allows you to create a service catalog, an already pre-built single sign-on, an already pre-built security OU and a sandbox OU. And what it does is it automatically sets up CloudTrail, AWS config. It sets up some enforcement and some compliance rules and does some like the preventative guardrails for you. And so it logs all the stuff, puts it into its own log accounts, does some cross-account auditing capabilities, and then you can provision accounts like a vending machine. You can create multiple accounts inside the control tower, and it will like allow you to create compliant, logged, tracked, auditable accounts, almost like candy, just coming right out of this control tower. And you can use single sign-on to grant access to all the accounts that people have access to. So if you haven't seen this before, it's worth looking at. It does have some limitations, which I'm just going to let you discover kind of on your own. Because if you don't run into them, they're not going to be a problem for you. If you do run into them, you're going to be like, woof. It's like Terraform. Terraform works great, but when you run into problems with certain key pieces, then you're using those use cases that's going to make a difference, right? But Control Tower is a great product. It just has a few edge cases where it's like doesn't work really well. Okay. But this is a best practice pre-built way for you to get a multi-account strategy inside of AWS. By the way you set this up is you go into one of your accounts, set it up as a control tower. It then goes in and sets up all the other accounts. The account that you set up the control tower in becomes the primary account, sometimes referred to as the master account. That's where all the billing occurs. The sub accounts like the security account, the log archive account, and the sandbox accounts, you all set those up separately. So just start in one kind of greenfield account and you can go from there. Any questions about what control tower is used for?
Can I programmatically set up all of this? Like hypothetically, can I use the CDK to write the SCP to define the OU and all the AWS accounts that fall underneath it?
You can, yeah. Let me say that theoretically you can, right? Okay. I say theoretically you can because I don't know that anybody who's done it with the CDK. So that's why I'm just caveating it. But I know for a fact that you can, with the CDK, you can set up SSO, directory service, you can set up sub accounts, service catalog, you can set up every component that's in here. So theoretically, I'm going to give you the answer is yes. I don't know anybody who's defined it manually, who like instead of just using the control tower. But there could be benefits to doing that, Rakesh. So it's not a bad idea.
Got it.
Yeah. Okay. Do a little knowledge check. All right. A, B, C, or D, and then we'll take a break. Not after just one question, after many questions. Which of the following can be attached to a user group or role? Well, they're asking, what can you attach to one of the core entities, the principal entities in AWS IAM? What would that possibly be? Now remember, a user, a group, or a role is an IAM entity, and it's an identity-based entity, really, right? Principal. So a lot of you put D, which is the right answer. It is an identity-based policy. Remember, STS is the service that grants tokens. So like, for example, just to say this, if you are inside your AWS account and you're like, I don't even know who I am right now, right? You can actually call the STS service and say, hey, by the way, man, who am I right now? What does it say? It says I'm Spartan Sage, right? This is one of my users inside of my account, right? So you can always call the STS, the secure token service, and say, hey, can you tell me who I am right now? Because I think I switched users, or I think I put in the wrong key. By the way, if it throws an error, it's probably because your key is malformed, your access key or your secret access key, just so you're aware. There's either a hidden character in there or something funky. Because if it can't execute this call, it means it cannot form the API call correctly, which means there's something wrong with some of the information that we inputted here, okay? But AWS STS get caller identity will, on the command line, call AWS and says, who do you think I am, right? So just keep that in mind. So STS is definitely not the answer in this case, because that's a secure token service. Security group is a firewall that wraps around an instance, so we know that's not right. And then resource-based policies get attached to what? Not users, groups, and roles. What do resource-based policies get attached to?
To resources like EC2 instances.
That's right. Also known as services, right?
Services.
So, perfect. All right, on to the next one. Which policy type is not assigned to security principles and can grant permissions to access a specific resource? It's almost like we just talked about this. Yeah, I think you probably all know just based on what we talked about. All right, what if I changed one word? What if I changed grant into deny? What would the possible answers be then? That could deny permissions to a specific resource. That's right. Now, don't get me wrong. B and C can allow grants, but they don't really grant. They allow grants, but they don't grant, but they definitely deny. So service control policies and permission boundaries will definitely deny stuff. Let me be clear also, the right answer would be A, B, C, and D can all deny, actually. So all of them can deny. So good. According to AWS, which of the following are benefits to using roles? I'm going to select two. All right, hold on. Let me ask a question just to make sure. When I told you that when you hear the word temporary, what should you think of? Anyone remember?
Roles.
Roles. Yes, exactly right. Both of you. Roles. You hear the word temporary, AWS instantly is like in their mind, they're like, whoop, roles, right? So definitely D, because the temporary permissions, that's definitely right up their alley, right? And then what was the one kind of use case that I gave? Well, it was actually cross-account access, right? Which you can't do that with a user, but you can do that with a role. By the way, the role goes in the account that you want to switch to, not into your account. you're going to take your user in account A and you're going to assume the role in count B. You're going to assume the role in count C. You're going to assume the role in count D. So remember, the role has to be created in the target account that you want to get into. So don't forget that. A lot of people think you're going to create the role in the account that you're already in. That's not true. You create the role. Think of it as like a character submit. The role goes into the account that you're going after. Can you use JSON, YAML, or JavaScript? We're just going to move on. That's just the question. Root user should not be used for daily administration of your AWS account. Is that true or false? I feel like there's probably one of those like bad, like, I don't know if it's Jack Daniels or Jim Beam memes where it's like, I don't test often, but when I do, it's in production. It's like, I don't do things in AWS often, but when I do it as the root user, right? So the answer is obviously true. Don't use the root user. Dos Equis, thank you. Don't use the root user. What did you say, Kyle? Sorry.
So much easier. Why go through all the trouble?
Indeed. Although you want to hear some people groan, I was teaching a Kubernetes class the other day, and just to mess with them, I actually SU dashed over to root just to see if anybody was going to make a comment about the fact that I just like completely became the root user instead of using sudo. I got some groans. People were paying attention. Okay. So what can simplify logins for customers using Active Directory, AWS accounts, and third-party services? Now, remember, I didn't say manage multiple AWS accounts. I didn't say get temporary tokens for use, for federation authentication. I didn't say manage users, groups, and roles with this service. I said I want to simplify logins. That's all I said. Right? The answer there would be B. Good. Okay. All right, when you come back, we are going to dip our toes into module 3, which is going to be networking. So we're going to talk about networking. So before we do that, actually, let me just check on one thing. And don't worry, I'm not going to shorten your break, so you're not losing any time here. I just want to check and see something, because we're going to do a little bit more practice exams. And there, we use this guy named John Bonso, who is he's got a photographic memory, amazing test writer. He works with AWS to make sure he doesn't violate any of their, constraints, because he didn't want to get sued for doing test dumps and stuff like that. Really good guy. I actually met with him with AWS, and he has practice exams that are just absolutely spectacular. But I wanted to check on something while I had y'all, because when we get back, what we might do is we might actually do some topic-based exams. Do we have IAM? Oh, we do. All right, so when you get back from break, because that's what I was hoping we would do. I didn't know if IAM was in there. That was my only question. Is when you get back, we're actually going to work on some practice exams just to kind of like reinforce the IAM knowledge, but to also just show you how the exam is bigger than the class. Okay. So I just want you to be prepared, is that when you come back, you're probably not going to know the answers to most of these questions. And that's the way it should be. If you knew the answers to these questions when we get back, then you probably shouldn't be in this class. So I don't want you to feel like you're failing, because if you start passing these questions, you're failing. You should be winning by not knowing what these questions are, because you haven't been through all of this yet. So just so you know, I wanted to frame that up properly. Okay. Meanwhile, let's say it's 3:25. We should take a 15-minute break. So 2:25 your time. So why don't you come back at 2:40? So that's like 16 minutes from now. And then we'll pick up the practice exams and then move on to networking. Okay. So I'll see you in 15 minutes. All right. Okay. So we're gonna take a moment just to run through a few of the exam questions. Just give me a feel for the exam. I'll talk more about the exam, by the way, on the last day, just to make sure you understand the scope and whatever. But to give you a feel for the kind of questions that get kind of covered in the exam, this is a topic-based practice exam just for solutions architect associates, and it is just for IAM. So these questions are just about IAM and whatnot. So what we usually do is I'll usually analyze the first few. We won't go through all of them. I don't even remember what the total number is. Oh, there's actually only 8, so maybe we will go through all of them. But I'll analyze the first few, and then what will happen is I'll give you a couple minutes to analyze the last few yourself. Okay. So, and this is pretty typical. The only thing is that they're not going to actually tell you like which section you're on. They're not going to tell you like the which domain of the 5 domains that make up the exam is it talking about. Usually it's going to go right into a scenario based example like this, right? So in this case, we got a tech company that's working for that has undertaken a TCO analysis, total cost of ownership. They want to evaluate the use of Amazon S3 versus acquiring more storage hardware. The result was that all 1,200 employees would be granted access to use S3 for the storage of their personal documents. Interesting. Which of the following would you need to consider so you can set up a solution that incorporates a single sign-on feature from your corporate AD or LDAP directory and also restricts access for each individual user to a designated user folder in an S3 bucket? So you're going to select 2 options here. Now, the way this works is that, you know, they're going to test, especially with the associate's level of knowledge, like they're going to test like your knowledge on several different levels, right? And there's a couple of things that Amazon just doesn't do typically during the exam. For example, one thing they don't do is they typically are not going to recommend that you use the third party. They might if they don't have a service for it, but if they have a service for it, they typically are not going to recommend a third party at all. So I'm just going to say this, I'll probably take that off the docket for the time being. Now, the other thing is that because you're an architect, right, and they're designing obviously for security in this particular case, but they also want you to do the thing that's the most resilient, the most performant, the lowest operational overhead. They're going to want you to do the thing that fits the 5 pillars of the, or 6 pillars, but mainly the first 5 pillars of the well-architected framework. They're going to want you to focus on that. So in this particular case, it says map each individual user to a designated user folder in S3 using workdocs to access the personal documents. I mean, that is actually what workdocs is used for. I don't know that there's a linkage between workdocs and S3, so that's maybe a little bit in question. Set up a federation proxy or identity provider and use STS to generate temporary tokens. That sounds reasonable, actually. Set up a matching IAM user for each of the 1,200 users in your corporate directory that needs access to a folder. That doesn't seem right, actually. So typically what happens is that you set up a federated identity provider, you create roles to grant access to a whole group of people. And in this particular case, since all 1,200 are going to get access to the buckets in question, you know, there's got to be some way to link each individual user with the bucket. But honestly, you could actually set up a policy that says, look, if the bucket name is not equal to the AWS username, then they can't get access to it, or some variation thereof, right? So my assumption is that if we're following best practice, you're probably going to set up some kind of identity provider, like, right, to the thing in question from their corporate Active Directory. And you want to restrict access to each individual user to a designated folder, you probably would configure an IAM role and policy to do it. That could be like a possible answer. But, you know, honestly, with something like this, it could also be like A and D could be a play as well, right? But let's take a guess and just like see, just without a whole lot of deep analysis, let's just see. Because sometimes you can overthink these things, right? You don't want to do that either. That could be a problem. Sometimes when you know a lot, you tend to overthink things. First thought, best thought. So notice that in this case, it's accurate, right? We know that we wanted to set up a federated proxy because they already had a corporate AD. And we know that we're going to use the token service because I mentioned this earlier just now when we covered the module, that STS is the underlying service that grants all the tokens for access. And then this, I don't think technically would work. Workdocs is like Google Drive. I don't think it uses S3 as underlying storage. Maybe it does, but it doesn't matter. That just looks weird. They're not going to recommend using a third party. And then this looks like too much work, right? Now, here's the cool thing about these study guides. He's going to tell you why these are the right answers, right? He's going to tell you why the other answers are wrong. First of all, you don't have to use a third party. Amazon actually uses tools for this. There's no way of integrating S3 with Workdocs, which is exactly what I was calling out earlier, because I don't think that's an option, right? By the way, Workdocs could do it by itself. So Workdocs could actually be used in this case instead of using S3, but that's a whole different discussion. And in this one, having that many IAM users would be unnecessary. Amazon wants you to go for the lowest operational overhead that you can, right? In addition, you want the account to integrate with your directory or LDAP directory. And here's the problem. You don't use users for that. You use roles for that. So if it said 1,200 IAM roles, that might make sense, although that would be a lot of work. But it didn't say that. It said users. So automatically that's the wrong answer. So you can tell that based on what you know about the services, not only will tell you what the right answer is, it will eliminate the other answers as being wrong. Now, be forewarned, this is a 130-minute exam, 65 questions. You have 2 minutes to read the question, do your analysis, and put your answers in per question. 2 minutes per question. That's it. So that should give you kind of an idea. Now, John also, by the way, and I'll talk about all this at the end. So don't feel like you got to remember all this because I'm going to cover it again officially towards the end of the class. But Tutorials Dojo, we provide, I believe that we actually provide an access to Tutorials Dojo for you as part of doing this course. So you will get access to this exact test to take. And this test, not this particular version, but the review mode set, not the topic-based set, is going to be the litmus test to tell whether or not you're ready to take the exam. I am going to cover every single detail of that the last day of class to make sure that you are very clear about what you need to do to know whether you're ready to take the exam. And it is all based on these questions that you're seeing here. The other thing to note is that John does provide the reference docs where he got the right answer, and he will provide either an overview or a cheat sheet or both if he has them. Like if you keep missing questions on IAM, you probably want to study the cheat sheet just to get an idea of like what it is you keep missing. Okay. It looks like some of you, you took a shot at answering. You actually got it right. It's good. All right. This time I'll actually ask. Okay. Company recently adopted a hybrid architecture that integrates its on-premise data center to AWS cloud. So this is hybrid, right? You're assigned to configure the VPC and implement the required users, roles, and groups and policies. What's the best practice when creating policies, right? So I'm not going to analyze the answers on this one. Just give me your best educated guess. Is it A, B, C, or D? It looks like predominantly most of you answered B. So I'm going to take a gander at that one. Now here's the problem. B's the textbook answer. First of all, this doesn't even make any sense. EC2 users are a completely separate thing from IAM users. So no. This one's good, as pointed out by Alex, because they were trying to trick you. Oh, we're going to give the least number of people full root access. No, we're not going to give people full root access. That violates least privilege among other constraints. So no, that doesn't work. And this one does the same thing because, you know, I'm going to give Gene access to a bunch of DynamoDB buckets and S3. Oh, and I'm going to make him an administrator for IAM, so he can have some additional administrative operations. No. You give them exactly what they need to do the task, no more. That's B, classic, right? So there it is. Pretty straightforward. Other references if you need them. Okay, we're on to the third question. Pharmaceutical company has resources hosted on both their on-premise network and on cloud, so a hybrid, right? They want all of their software architects to access resources on both environments using their on-premise credentials, which are stored in Active Directory. What are you gonna do? A, B, C, or D. I just want to point out, by the way, that Amazon does this a lot. They'll give you two answers with slightly different twists on them. Typically, one of those is the right answer. Okay, you all seem very confident that B is the answer. Let's take a look. Looks like it is. By the way, when would this be the answer? If I wasn't storing it in Active Directory, if I stored it in what, would then A be the answer? Not necessarily Web Identity Federation. Not Okta per se. If I was using Google or Facebook or Amazon or some other known web identity provider, right, to log in, that's probably when I would use Web Identity Federation. Now, Dave, you might be right. I have no idea if Okta actually supports that or not. It might. You probably know more than I do about Okta. But typically that's for when that like Google or Facebook, like you want them the user to log in as their like Facebook user or their Google user or their Amazon user or whatever. That's when Web Identity Federation is typically used. But yes, I know Okta definitely supports OIDC. So, and I believe it supports SAML 2.0 as well. So that's when you would see the first one kind of come true, right? Where it's like, but in this case, they said Active Directory. So you're not using Web Identity Federation. You're not using WIF. You're using ADFS. The rest of this has to do with networking. So no, and that's just a no. That has to do with users. So just a no. Okay. An intelligence agency has developed a missile tracking app that is hosted on both development and production AWS accounts. The intelligence agency's junior developer only has access to the development account, but she's received security clearance to access the agency's production account, but the access is only temporary and only write access to EC2 and S3 is allowed. Which of the following allows you to issue short-lived tokens that act as temporary security credentials to allow you to access resources? A, B, C, or D? You all seem pretty confident on A. Let's check it out, see what it says. Which of the following allows you to issue short-lived tokens? I mean, you with temporary security credentials, you're done at that point, right? That's STS, that's classic. Now, don't get me wrong, Cognito can actually issue JWT, but that's usually used for application users, not for IAM users. So then that makes that wrong, and then single sign-on is just single sign-on. So, yeah. Okay. Yep, just checking that out. Okay. A mobile app stores pictures in S3, allowing application sign in using OIDC compatible identity provider. Which STS approach to temporary access should you use for this scenario? So Google and Facebook and all those guys are actually using OIDC, OIDC, like compatible identity protocols. You all seem pretty comfortable, right? Let's check and see. Makes sense, right? So we're not using SAML base, right? We're not, but we're going to use WIF in this particular case because it is OIDC compatible. So note that cross account access doesn't even make any sense. And this also doesn't really make any sense to use roles with STS. That's kind of inherent, actually. What we need to do is make sure that we can, how does STS know that it can trust the the OIDC compatible identity provider? Well, there has to be some kind of federation that happens. That federation is that trust relationship, and that's what the Web Identity Federation comes in for. Now, if it had said SAML based, like it was SAML 2.0, we could have used that as an answer as well, but it didn't say that, it just said OIDC. Good. All right, an SA is managing a company's AWS account of approximately 300 IAM users. They got a new policy that requires changing the permissions of all 100 users that control the access to the S3 buckets. So there's 100 IAM users that control access to the S3 buckets. So what's the SA going to do to avoid the time-consuming task of applying the policy to each user? Good. Standard that we talked about, right? Create a group, add their users to the group, apply the policy to the group. Easy peasy. You don't have to go through and then add that policy in line to each user. You just put all those users inside of a group, go to town. Okay. Last two. Company needs to integrate LDAP from the on-premise data center to the AWS data center VPC using IAM. The identity store, which is currently being used, is not compatible with SAML. Okay. So which of the following provides the most valid approach to implement the integration? I see a bunch of very confident and semi-confident A's. So let's check this out. So here's the deal, right? If the identity store is not compatible with SAML 2.0, then you're going to have to build a custom identity broker to perform a similar function, right? So the problem with single sign-on is because using an IAM policy is not enough to integrate your LDAP service to IAM. In other words, LDAP can only be integrated in by basically connecting in through, either OIDC or SAML 2.0, right? But it's not compatible. So in that particular case, you've got to use some kind of STS approach, right, to basically get this broker to talk with STS. Without that connection, you're not going to get that to function. So this isn't actually going to solve the problem. Indeed. Use a real LTAP provider. Do you know of any third-party service that you could buy, or even the open source one that doesn't actually support that? Anyway, it's a good scenario as far as like knowing what the limitations of the service are, but that probably wouldn't happen in real life. Good. Use an IAM policy that references that doesn't even make any sense because that's not how that works. Use IAM roles to rotate the credentials. No, that doesn't make any sense. There's no linkage between LDAP and an AWS IAM, so that doesn't make any sense. This is the only one that provides the proper linkage based on the current constraints. Good. Notice this process that's eliminated here, where the user basically logs into the broker and then gets authenticated first. Once authenticated, because there's a trust relationship, STS is going to grant some security credentials, which then it is going to allow the user to get either redirected to the console or access the EC2 instances or API in this particular case. Notice that in all cases, the user has to log into the local identity store first, and then they can get access to AWS. So if there's an identity broker on the corporate side, they have to log into it first. That's always the first step. All right, last one. SA creates a brand new user with the default setting using the CLI. Okay. This is intended to be used to send API requests to Amazon S3, DynamoDB Lambda, and other resources. Which of the following must be done to allow that user that was just created by default through the CLI to talk to other AWS resources? So by default, if you don't assign permissions to a user, what permissions does a user have?
I want to say nothing, but by default, so do I have to explicitly allow a user to also assume a role? So what happens if I don't even allow a user to assume a role? So basically they can do absolutely nothing, not even assume another role.
Well, right. In other words, they have to be able to they have to have that permission, right? But let's say maybe we're wrong. Maybe it's not D, maybe, right? Maybe instead, you're gonna have to create a set of access keys for the users and attach the necessary permissions. Now, so this was a two-step process, right? Which is what made this weird, right? So AWS, by the way, will do this a lot because technically this is actually the right answer, is that you need to attach some permissions. That's basically what this said, right? You following me? The thing that's weird about this question is that does it state in here that the user is going to be using the CLI in the question? It doesn't.
It does not.
It does not. And yet this is supposedly the answer, right? Because if you create access keys, that assumes either you're using the CLI or programmatic. So just know that sometimes there's squishy questions in here, because out of the 65 questions, just so we're clear, only 50 of them are scored. And so John has created 65 question tests that include squishy questions like this, because this is what you encounter on the exam, right? So I would assume this question is probably not going to count as scored because there's no right answer for the whole thing, because technically D is the right answer. It mentions nothing about the CLI. So just know that you will run into questions like this where you're like, no, it's D is definitely the answer. And the problem is that they'll say A is the answer, and you're going, by what justification? So let's like take a look, for example. Like I'm kind of curious, like what John said about this. Do nothing to not. Oh, okay, fair enough. He is using it to send API requests. You probably wouldn't do that through the console. So you could infer that he's using either the CLI or the programmatics. So I stand corrected, right? In this case, actually, that does kind of make sense. He is actually We are sending API calls that can only be done through the command line or through the SDKs, CDKs. Fair enough. You're right. We could make that extra leap if we wanted to and assume that we need access keys and secret keys. My point being is that this question is still squishy and you're going to run into questions like this every once in a while. So when I took the machine learning exam, by the way, and the recertification in early, like late January, early February, I got 7 questions wrong right off the bat because it asked me a bunch of questions about services I had never heard of right off the bat. For the first time in my entire career, when I hit submit, I was pretty sure I had failed the exam. Turns out I had gotten it right. And matter of fact, I got almost a 900 on the entire setup, which that exam is pretty hard. So I was pretty proud. I did better on that exam than I did on the DevOps exam, which I was very confident about. And the main reason is that I forgot that there's a bunch of unscored questions in here. So just know that there's going to be some wacky questions in here because John is emulating exactly what you're going to run into in the exam. This is one of those squishy questions where you're like, do you really want me to infer and draw that extra step? Maybe, probably. So just be on the lookout for this kind of thing. Don't let it take the wind out of your sails. But about 1 out of every 7 questions is going to be like this. It's going to be a little weird. Okay. In this case, technically they're right. We could have assumed, since we're sending API requests, we're not using the console. Okay. And that was the last one. How do we do? We got 75%, right? We passed. We would have passed that section. All right, so that gives you an idea of kind of what the questions are like. So, you know, what we'll do is as we go through other sections, we'll take the time to do the practice exams as well to give you a feel for how all that goes down. Okay. Any questions about any of that? Let's see, passing score, I believe, is 750. I don't think it's 720. Believe it is 750. It's funny because I just talked about this yesterday and I can't remember. 50 questions that affect your score, 15 on score. There it is, 720. So the passing is 720. So technically you need to pass 36 questions out of the 50 to get right answers. So it is a 65 question exam. I'm just saying that only 50 questions affect your score. There are 15 unscored questions. So it's a total of 65 for the 130 minutes that you take it for. By the way, this exam guide also includes the domains that I was referring to earlier. Notice that, you know, 54%. Notice that almost 60% of the exam is about designing resilient architectures and then designing high performing architectures. And then another quarter is about security or cost optimized. Connor, you can do both if you want to. I will tell you that if you do virtual testing, you have to take everything off your desk. Like you can't have a second monitor. You can't have any equipment on. You can't have kids or pets anywhere in the house. Just so you know, like it's pretty fierce. My son was being silly and he burst in one day and he started yelling S3 is the answer because he knows a little bit about what I do. And the proctor didn't find that funny. So luckily he just gave me a warning and my son got out. But like, you know, sometimes going into the testing center is better. Just FYI. But they are doing virtual and there's no cost difference. Yeah, you can take pictures of all 4 sides of your desk. You can take pictures underneath if it's not see-through. You can't cover your face. There's no breaks, no scratch paper, none of that stuff. I'll talk about some of those limitations on the last day, but yeah. I actually prefer to go into a testing center. It's just like 15 minutes down the road. I can't imagine what they have to deal with either, like people trying to cheat or whatnot. I can't imagine what they have to deal with. Okay. Let's move on past this last module. Yep. And let's talk about networking. All right. Okay. So we spent most of the morning just getting comfortable with access, doing our first lab. We did a little bit of account security. Now we're going to talk about a little bit about base networking. This is going to be relatively simple and straightforward. Not as much of a deep dive into networking as it has been in the past. But still IPv4 and IPv6 are, it's all relevant. This is another one of those questions that Amazon asked, and I'm just kind of like, how are people supposed to know this? For your entire business, what percentage of your workloads are publicly accessible? I'm like, Amazon, I don't think most people know the answer to that, actually. So I do not actually know what you all do as a business. Are you a consulting company? Do you do like real estate? Do you your insurance? What do you guys do for a business? Oh, I would imagine quite a few services then wouldn't necessarily be publicly accessible. Gotcha. That means that what would explain also probably why security would be a little bit more paramount. Okay, good to know. That means HPC is probably a little bit more paramount as well, right? As far as performance and latency. Okay. So here we are. Here's our call to action. So everything starts with network engineering with this, with basically with security. But we want to make sure everything's isolated. We want to make sure that routing is controllable. We want to build highly available networks. Can you support advanced routing protocols? Can you support IPv6? How do we prevent distributed denial of service attacks, other layer 7 attacks? Like what can we do here? So, and the questions that we're looking for, the objective is how do we build these dynamic and secure network infrastructures? How can I segment my IP addresses and my subnets? And how can I direct and filter traffic that's moving in and out of my network? This is where we get back to our drawing, where we've got a VPC sitting inside of a region. We got some public subnets. We might have some private subnets. We got more private subnets that might happen, right? And then somehow that's got to get to the internet. Somehow that's going to do DNS resolution. Are there firewalls in play here? It's a bunch of questions. So let's talk about these three fundamentals. So first, how do you plan IP space in the cloud? Well, I do want to point out one little thing before I go forward with this. I found this cool little thing the other day. Amazon now has this VPC IP address manager. Everybody else seen this? Anyone else use this already? So basically, you can just use IPAM to monitor your space across your entire organization or for a single account, which is really cool. So it basically allows you to monitor IP addresses across, right, your entire set of accounts, and to make sure that there's no overlap, right? Because that can cause a big problem when there's overlap in your IP address spacing. So, this is something they just added in here. And, VPC used to traditionally be under AWS. So, sorry, under EC2. So this has already had its own kind of huge set of options, everything from all the security firewalls, network reachability. You can do RSPAN. So if you want to do traffic mirroring, you can. There's WAN managers and VPN and firewalls, DNS firewalls. There are all kinds of stuff here, right? Which most people aren't aware of. So, what we're about to talk about is just the base fundamentals of what's possible from a networking perspective inside of AWS. Now, here we go, right? So these are the two types of IP addresses you might be familiar with, right? This is IPv4, developed back in what, the 80s, late 70s. Uses 32-bit addresses, 4 octets of 8. They're grouped into 4s. So they're written using kind of a base 10, decimal notation. This is where DHCP, passes like different option sets and whatnot into the IP addresses. This total, by the way, allows for about 4.3 billion addresses. So so then RFC 1918 came out and said, look, if we're using a 192.168, right? If you're using a 10 address, if you're using a 172.16 or all the way through a 172.31, this range is private. And so you can use that privately on whatever internal networks you want. So what happens is that a lot of people create all these like massive 10 networks and these 172 networks and these 192.168 networks, and they're scattered, behind all these like corporate firewalls, and people will have to translate them into public IP addresses in order to get all this stuff to work. Because without a public IP address, these RFCs like the 172s, the 192s, and the 10s, they can't actually they're not routable across the internet. So IPv4 was a great idea because no one expected everything to get an IP address. And then someone said in the late 1990s, they said, look, we're going to run out of IP addresses. Why don't we just go ahead and go from 32-bit addresses to 128-bit addresses? And so everybody's going to be internet enabled. So no more private IFC ranges, although some people have by convention allocated ranges for internal use only. So this allows, IPv6 allows for about 340 trillion addresses, right? So meaning every device can have a unique IP address. This uses like an alphanumeric hexadecimal notation. So you're going to see numbers and hexadecimal like letters basically inside there. So do note that because AWS's backbone is all IPv4, while you can enable IPv6 and disable it, you can never disable IPv4. It must always be at play inside your environment. Now, this is a classless internet domain routing. The way this kind of works is that you're going to specify a set of IP addresses in the form of a CIDR block. So this could be a 10.0.0.0/16. It could be a 172.31/16. I mean, there's a variety of different options and possibilities here. So the size of like an IPv6 block, by contrast to IPv4s, is fixed to a /64, just so you know, right? And by default, all VPCs must have at least one IPv4 CIDR block. You can't change this, right? So notice that with IPv4 in particular, if you're at a /16, meaning you're taking the first two numbers for the network definition and you're using the rest for hosts, you're going to get 65,536 IP addresses on that network. And that's like a postal address, right? This is what the computers use to talk to each other. No surprises there. Do note, by the way, if you do 0.0.0.0/0, that means I want all IPs to go over to this place. If you use the /32, you mean this specific IP, right? So this is all standard notation, especially if you do any routing or deal with any firewalls. Now, you can make a subnet inside of a VPC, inside of your account, private, which means it does not have direct access to the internet. Or you can make it public, which means it has direct access to the internet. And if the firewalls are disabled, which by the way, they never be disabled. Like you can open them up to the entire world, but the firewalls are still there. They're just allowing all traffic to pass through. If you have a public IP address on a public subnet, then that means you can get to the internet, and if your firewall lets it, your internet can get with you. Now, just know that every single, for example, EC2 instance always has a private IP address, even if it has a public IP address attached to it. So remember, those EC2 instances never really give up their IP addresses. So just remember, you can have public subnets, private subnets, they sit inside of a VPC. As a general rule of thumb, do not stick any of your infrastructure on public subnets. If you want to share something out with the world, put a load balancer, which sits on a public subnet, in front of that object, and then point that load balancer to the service on a private subnet. So let Amazon have to worry about defending that load balancer. You keep your stuff off the internet, off of public subnets.
Does the load balancer handle the net?
No, if you're talking about initiated outbound connections, Kyle, no. If you're talking about responding to a connection, yes.
Okay.
Right? Because if someone comes in and hits the load balancer and the load balancer talks to the web server and the web server responds, it just goes back out through the connection, right? If you're talking about the web server outside of the load balancer initiates a connection to go get patches, yeah, you're gonna need to do NAT. You're gonna need a NAT gateway at that point in time for that to happen.
Got it.
Yeah, it depends on who initiates the traffic. If it's initiated on a private subnet, you're gonna need a NAT gateway. If it's initiated, outside to go into the subnet and go back out, as long as that socket's there, it's gonna maintain a connection to go in and out. So it just depends on where the traffic's being initiated from. Hold on one second. Anyway, sorry. My AC system decided to start talking to me. All right, other questions? Okay. Now, we keep talking about VPCs. What are these things? VPCs are the fundamental kind of networking unit, like the macro unit, not the micro, the macro. They're the macro unit, the macro category inside of AWS. So think of VPCs, virtual private clouds, as a networking pie. You want to make that pie as big as possible. And then you can put subnets in that pie, and you want to make those subnets as big as you possibly can. And each subnet goes inside of an availability zone. So take a look at this. So VPCs can eat an entire region. They cannot go across regions. So you can have a VPC in Virginia, a VPC in Ohio, a VPC in Oregon, a VPC in Northern California. And in, for example, the Virginia region, there's a VPC that goes across all 6 of the availability zones, because for some reason there's 6 inside of Virginia. Probably because that's where AWS was born, right? There's 6 availability zones inside of Virginia. And if I want to create 6 public subnets, 1 in each of the availability zones, I'm going to need all 6 of them, because subnets cannot span availability zones. So notice that this guy isn't running over here into availability zone 2. It can't. Subnets are constrained to a single availability zone. No arguments, no negotiations. Okay. Now, if there was an availability zone 3, there would be another public and a private subnet. Now, the main distinction here is that if I take a VPC and I take a 10 address, and let's say, I divide it up into a /22, that gives me 1,024 total IP addresses in that VPC pie. That means I could make 4 subnets right? with 250 something addresses apiece. They may say, Michael, well, hold on. I thought it would be 256 IP addresses. Amazon takes 5. 2 of them are taken for networking. Amazon takes 3. Sorry, that's probably not accurate. So, for example, if that was a 10.0.0.0, the 0 is a network address. The 255 is the broadcast address, and Amazon takes 1, 2, and 3 off of the beginning of every subnet. Why? Because it needs one for routing, one for DNS, and another for DNS. So just roll with it. So just know on a subnet level, when you define a subnet, you're going to lose 5 IP addresses. So this VPC had 1,024 total addresses. And what ended up happening is that they created 4 subnets. It looks like 2 publics and 2 privates. And they each lost 5 IP addresses apiece. Okay, so then how do we get to the internet? That's my question that's been asked. Well, note here that a public subnet can just go out to the internet and the internet can get to it as long as the firewalls allow it. Amazon by default, by the way, has 2 firewalls that are active on any VPC to EC2 connection. Notice that this guy doesn't even know where the internet gateway is, even though it's right next to it, so it can't really do anything. Note here that the way this works is that this is a public subnet because the route table over here knows where this is. This is a private subnet because this route table over here doesn't know where this guy is. It has no connection to the internet gateway. It does not know. Okay. So each subnet, by the way, in your VPC has to be associated with a route table. Now that can be the route table that is like the VPC's route table, or it can be its own individual route table. If you look here, by the way, notice that the default gateway for this public subnet actually points to what's called the internet gateway, which is this little device over here. Now the internet gateway looks like a single point of failure device. It's not. It's a virtual device that has n number of virtual routers underneath it. So it's not a single point of failure. And that thing, by the way, I've tried to crush that thing with terabits of traffic, and I've never been able to overpower the internet gateway. Not to date. I'll keep trying. So here we got a public subnet. Here we've got a default route. That default route points towards the internet gateway. Again, virtual device. Sole job is to accept traffic that's bound to the internet. I do want to point out that this is a 2-way door. So traffic can go out and traffic can go in. So just know that while there are firewalls here and here, okay. Here we've got a private subnet. Notice there's no default gateway here, right? So while I've got a default gateway for my public subnet, for my private subnet, no default gateway. So the private subnet has no path to actually get to the internet gateway. Big distinctions. Sorry, my Zoom was telling me that my internet connection was unstable there for a second. So if I froze, please ask any questions if I froze for a moment. It's weird. Okay, so public subnet, private subnet. Notice the only distinction again is, does it have access? Does it have a routing table entry to get to the internet gateway? Okay. All right. Now, you got a VPC, you got a public subnet, you got a private subnet. You've got routing tables for both. You got an internet gateway. The public subnet knows how to get to the internet gateway. The private one doesn't. Note that Amazon, just to make things easy for you when you want to like mess around, has default VPCs with default subnets in almost every region that you plug into. So if you ever want to mess around with something, Amazon has default VPCs. Please do not use these in production. Make your own VPCs to use them in production, because like they are completely unrestricted. There's no firewalls aren't active. You know, the minute you put an IP address up there, it's going to be, you know, associated with the internet. Like, set up your own stuff for that. Don't use Amazon stuff out of the box for that kind of thing. Okay. They are very useful, by the way, for proof of concept, because they're just right there. Now, a couple questions, just reminders. VPCs can span an entire region. Subnets are constrained to one and only one availability zone. So we'll make sure that's super clear. A public subnet can be in one availability zone. If you want to put it in a second availability zone, you got to put a second subnet there. You want a third availability zone, you got to put a third subnet there. Make sure that's very clear. Some people will put in multiple VPCs, but most people go to a multi-account strategy, so it's less popular than it was. But like, for example, if you have a production AWS account and a non-production AWS account, in the non-production account, they'll put like a QA VPC, a staging VPC, a couple of development VPCs, and they'll all have very similar environments with them, but they won't be in the same VPC. So keep that in mind. If you like want to make something accessible within a VPC, first of all, just know that it must be in a public subnet, and it also must have a public IP address assigned to it. Now, that could be assigned from the DHCP servers that are in the subnet, or you could assign what's called an elastic IP address to the EC2 instance. Once it has a public IP address and it's in a public subnet and the firewall will allow it, then traffic can get into the box. Has to have those three things: on a public subnet, own IP address, and the firewall must allow it. Once you got those three things, you're good to go. Now, I said before that you could grab an elastic IP address. Do note that if you're worried about IP addresses changing because the boxes are rebooting and all that stuff, and you want to make sure the box consistently has the same IP address, if you give it an elastic IP address, which the only time Amazon charges you for an elastic IP address is if you ask for one and you don't use it. And it says you can only get 5 elastic IP addresses. You can get like 20. 30, 40. You just have to ask Amazon for them. That's all. And notice that IP address can be moved around, so you can move it to other systems if you want to. Every VPC has subnets, and when an EC2 instance is booted up, you have to say what subnet you want it to use. That's done through these elastic network interfaces. So this is a card, like a network card inside the VPC, that actually could have things like lambdas associated with it or VPC endpoints. But you can actually take a network interface and move it off of one EC2 virtual machine and put it onto another EC2 virtual machine. You might do that if there's some kind of like restriction involved, like maybe you are you have like some software licensing or something that requires a MAC address. That's one reason that you might do something like that. But it will allow you to basically move an IP address and its network card over to another box if you need to. I found nowadays in modern computing, I found very rare use cases where I need to do that, but you can if you need to. Most of the time we just solve this with a load balancer. Okay, what about NAT? What if you're not worried about inbound traffic and the responses? What if you're on a private subnet and you want it to be private, but you need to be able to still get patches and stuff from third parties? How does that work? Well, most of the time they create what's called a satellite server. So like if it's Ubuntu, you just create like a Yum repository. But what if that Yum repository is private? How does it get access to the internet, right? Don't you need a proxy or something to get out to the internet? And the answer is that you do. So here, notice there's an EC2 instance. And what would happen is that if that EC2 instance wants access to the internet, it's going to talk to the route table, which is then going to redirect it to the NAT gateway, which is then going to talk to the internet. Let's say it's a customer or a website, and then everything's going to come back through that same transmission. So it's going to have a pipe, right, where it sends traffic back and forth. So if we see that in a little bit more detail, notice that the route table for the private route table at the bottom, notice that its default gateway is the NAT gateway, which is very fascinating because that means that every EC2 instance here is going to send its traffic by default to the NAT gateway. It's going to send its traffic by default out here. And when responses come back, the NAT gateway is going to send their traffic back to this guy. Good. So this is how you connect private subnets through that NAT gateway service into the internet gateway and therefore out to the internet. Now, it used to be that you had to roll your own NAT gateway instance or your own NAT instance. We don't do that anymore because Amazon has what looks to be a highly redundant device that does it for you on a per availability zone basis. So if we go back to our big old map, our diagram that we were looking at before, notice that this now should make a little bit more sense. The app servers in our drawing were on a private subnet, so were the databases, but they were talking to this NAT gateway to initiate outbound traffic. But meanwhile, by the way, the auto scaling group was sending traffic to them as well, and it was accepting responses, right? There is such a thing as an egress only internet gateway. This gateway, by the way, is really only for IPv6. So it won't allow inbound connections. This is if you have an IPv6, you've enabled IPv6 networking and you need to be able to egress IPv6 out across the internet. It won't allow inbound connections though. So I don't remember how that got handled from an inbound IPv6 perspective, but you can only egress with that gateway. You can't inbound on it. I don't think Amazon supports currently ingressing IPv6 traffic. Notice the default gateway entry for that custom route table. Look at this. Oop. It's : /0. Means that anything that matches anything there, you're going to go talk to this egress only internet gateway down here. That's it. That gateway, by the way, is just like the internet gateway. It's just like the NAT gateway. It's horizontally scaled, redundant, highly available. So it's not a single point of failure. So don't worry if you just see one of them. It's not a single point of failure. Okay. Questions of any type about VPCs, subnets, public or private subnets, internet gateways, NAT gateways, or egress only internet gateways? It's a lot.
When you put the firewall rules, would they be tied to like a NAT gateway to allow only the specific outbound communication?
In other words, if you wanted to limit certain outbound ports, how would you do that?
Right.
So you would probably limit that from a NAT gateway, from a network ACL perspective, because the NAT gateway doesn't have any like outbound port limitations. In other words, you'd have to do that at the network, the NACL level, right? In order to prevent outbound traffic from going out, you'd have to deny that outbound target. But I don't think in the NAT gateway, I don't think there's a way to say, hey, I only want to accept like port 80 traffic, or I only want to accept 443, or I only want to accept port 22. Don't think there's a way to do that in the NAT gateway service that I've ever seen. I've only ever restricted it at the NACL level.
Oh, okay. Yeah, that's what I'm thinking. I guess that gets tied to the resources like the EC2 or.
The NACL is tied to the subnet.
Oh, I got it. Okay.
Yeah, it's the subnet firewall. So the NACL is the subnet firewall. The security group is the EC2 firewall.
Okay, thanks.
Yeah, we're gonna talk more about we'll talk more about firewalls. But I think you teed me up, Kyle. I think that's the very next thing we're talking about. Yeah. So when traffic comes in and out of a VPC, what ends up happening is that traffic's going to hit the internet gateway, go through the routing table, hit the boundary of the network. What is that? The boundary of the network is the network ACL. That's what makes up this public subnet. And then it's going to hit the boundary of the security group, and the boundary of the security group, just to be very explicit here, is set to this. So what's happening here is that it needs to get past this network ACL, past this security group, and then it can talk to the instance. And that's assuming the instance doesn't have its own host-based firewall, which it might. And so when the instance wants to initiate outbound traffic, it's got to get past the security group, past the NACL, through the routing table, and then out through the internet gateway. So there's this whole flow that happens here because the main security checkpoint or enforcers are here and here. The rest of these are not really enforcers. They can hide stuff, they can obfuscate, but a network ACL can look at traffic and go like, hey, you just came from Norway and you've been hacking us all morning. The answer is no, we've been blocking you. Security groups, by the way, by default block everything. You can only allow stuff to happen with a security group, which is why I didn't mention that earlier as an option for blocking traffic. Security groups won't block traffic. But I will tell you that with the NAT gateway, you can't actually set it so that you can only, will only allow certain ports to go into the NAT gateway. So that might be where you could restrict 443 and 80, right? I'd have to try that in order to verify it. So network ACLs are a firewall that's at the perimeter of the subnet, not the VPC. Public subnet, private subnet, it's got a network ACL boundary attached to it. Notice that this is a rule-based firewall, so it evaluates based on rules. So as you can see here, it's doing an allow, and then there's a catch-all that's like a deny. So it's going to allow web traffic. It's going to allow any other range traffic against these sources, which basically is anybody. That's what 0 to 0 / 0 means. Notice that this is the inbound rule table. If someone tries to get out, if they're not between ports 1024 and 65535, they're going to get denied. So just know that you can have inbound and outbound rules for the NACL for a subnet. So that's where you could potentially, Kyle, filter out the NAT traffic. You could also do it at the perimeter of the subnet and say, look, I don't want anybody talking to this instance unless it's on port 22 or via FTP only.
Got it.
Yeah. Unfortunately, the thing that's missing from a security group that won't allow it to participate in this kind of behavior is that a security group does not have a deny function. Security groups can only allow. By default, they'll deny everything, but you can't get them to explicitly deny specific things. You cannot add a deny rule to a security group. So. Did I write a drawing? Let's see. Rules are evaluated with the lowest number rule. Exactly. That's exactly right. Now, security groups are different because NACLs are stateless. Security groups are stateful, which means they track inbound and outbound connections. They track who was talking. And if you know, Rakesh and I are talking and I have permissions to talk to Rakesh and he responds, the security group will remember that I had permission to talk to him and will assume that he has permissions now to talk to me, to respond to my question. Now, if Rakesh initiates a question with me, the firewall's going to go like, look, no, like Michael's got to initiate it. You know, so just know that security groups are stateful. They're tracking connections, but they only track them from the originator to source and source to originator. They won't allow the source to talk to the originator, and but they will, you know, they'll obviously allow the originator to talk to the source. Notice here that we've got security groups wrapped around 2 EC2 instances sitting inside of a public subnet. By default, security groups will block all inbound traffic and they will allow all outbound traffic by default. Okay. If you want to add custom inbound and outbound rules, that's fine. Just note that these are all allows. These are all just allowing things to happen. Now, the cool thing about security groups is you can chain security group rules together and say, look, if you're okay, then you can go forward. If you're okay, then you can go forward. In other words, you could say, look, the web servers can always talk to the app servers and the app servers can always talk to the database servers, but nobody else can talk to us. So you can set up exclusion by chaining your firewall rules together. So here we are back to our original multiple layers of defense. So we've got internet gateway, route table, then the network ACL with its like subnet firewall. Then we've got the security groups with their stateful firewalls around each instance. Here's a quick comparison chart to think about. Security groups only support allow rules. This comes up on the exam all the time. Use a security group to deny traffic. You can't do that. Like you can deny all the traffic, but you can't deny a subset of the traffic. Security groups are stateful, NACLs are stateless. A security group will read all of the rules before making a decision about a packet. A network ACL is going to read each of the rules no matter where you are, what you're at, or where you're doing, where you're doing it. So security groups need to be manually assigned to instances, but the minute you stick a system inside of a subnet, it automatically gets the perimeter firewall, okay? So remember by default also that NACLs are wide open by default, meaning there's no restrictions, but with security groups, anybody who tries to get into a system by default is gonna get blocked. You have to open up that system in order for it to get like hacked or messed with. Okay, let's do a little knowledge check. Okay, so I asked you this before. Can a single Amazon VPC span multiple regions? Is that true or false? Good. Good. False. That's it. Wait, was that the only question? Hold on one second. That can't be it. I must have made a mistake here. I must have hit the wrong button. Let me check on this. Let's try that again. There we go. I was like, there's no way there's just one question here. All right, what action must you take to make a subnet public? There were three things, but which one of these do you need to do to make a subnet public? Remember, involved a route table. That was the thing you needed to change in order to make either a subnet public or private, right? So what needed to happen in order for that to function is that you needed to make sure that in the route table, your outbound traffic was pointed towards the internet gateway. Otherwise, people could get into you, but you couldn't respond to them. So you've got it. If you want to make a public subnet, you have to set the default gateway in the route table to point towards the internet gateway. That's required.
So the point more being that it's public, it's able to get to a public space and not publicly accessible.
Well, remember, communication is bidirectional, right? So let's say that you don't have the outbound traffic set up in the default route. People might actually be able to get to your IP address, but when the server tries to respond, it can't get to the internet. So then the person will never know whether they were successful because their packet will never get back to them. Right? So it's funny. You could have a public IP address on a box, on a subnet, and people might even be able to like send the packet, but they'll never know if the packet got there because there's no response. There's no conversation. It's just like you were talking at me and I'm not responding. You have no idea whether I'm paying attention or not. But the minute I put that route table so that the internet gateway is the default route, I can now talk to you. So we can actually have a conversation instead of you just sending words my way, right? Anybody else have questions on that? Because that can be a weird concept. Okay. What function does the NAT gateway service serve? What does it do? What does NAT do? We probably all know this from our homes, don't we? Good. Allows internet traffic initiated by private subnet instances. Good. Hope I made that, use that word correctly. In other words, if you're initiating traffic and not just merely responding to a load balancer's queries, you need a NAT gateway in order to get out, right? Good. What should you use to create traffic filtering rules for a subnet, for an entire subnet, not an instance, but a subnet? Good. I'm laughing a little bit. My AC has decided that it's just needs to be 53 degrees in here, and so it's doing nothing but blowing cold air on my eyes. It's crazy. Which ports are open by default when you create a new security group, right? So when you create a new security group, is inbound open by default? Is outbound open by default? What's open by default when you create a new security group? Now you get to select two here. So I noticed that some of you answered A and some of you answered D. Good. Yeah, so nothing is allowed inbound by default. So you are protected from the internet, but the box can get out to the internet all it needs to, right? To grab patches or whatnot. Excellent. Okay, I know this is gonna sound weird. I need to take a moment before my eyeballs freeze off. So why don't we just take a 5-minute break? I know we're gonna go till 5:30, 4:30 your time. So why don't we just take a 5-minute break, come back at 5? So just quick bio break and we'll be back. And then we're gonna close out with a round of practice questions. That's probably what we're gonna spend the last little time doing. And then we'll pick up the lab and the rest tomorrow. Okay. So I'll see you in about 5 minutes. So let's come back at 5:01 now, since I just talked for a little bit. 5:01. I'll be right back. Okay. All right, let's switch topics here. No. Let's go back up here. Let's do a few questions really quick on VPCs. I want to say, I think you all did really good on the last set of questions. So I don't think you all are far from, I think it may not be the full 8 weeks of study. I don't think you all are super far from being able to take the SA Associates based on what responses I saw thus far. So just know that our system, again, no guarantees, but traditionally has an 80% pass rate, which AWS constantly is flabbergasted by. So we know that our system works, but just to say this, we got really good at assessing whether people are ready or not. And most of you sound like you're pretty close. So I'll have a very clear picture by the end of the 4 days about whether or not any of you are in serious need of study. But based on the answers I got thus far, some of you are pretty close already. Only 4 questions here. So we'll do this and then we'll cover, well, actually, that's a good question. Hold on one second. Well, we might talk a little bit about compute because that is actually part of the day, and it's a long topic, so a few minutes there wouldn't go awry. Okay. All right, so we've got a large insurance company has an AWS account that contains 3 VPCs: Dev, UAT, and Prod. They're all in the same region. UAT is peered to both Prod and Dev using a VPC peering connection. Now, we haven't talked about this, so this is outside of scope, right? All the VPCs have non-overlapping CIDR blocks. So the company wants to push minor code releases from Dev to Prod to speed up time to market. But I want to be clear about what they're telling you here. They're saying, look, I've got Dev, and then I've got Prod, and then I've got UAT, but this is what they just told you. They said UAT is peered to both Prod and Dev. And then now they're off saying, I want to push minor code releases from Dev to Prod, so this way, to speed up time to market. So now what options are going to help with this? I'll let you look at the answers. Okay. So I saw a couple of answers. We haven't covered VPC peering yet, but honestly, you probably would know the answer right off the bat. So I'm going to go with the first answer I think I saw. Was it C? Do nothing since these 2 VPCs are already connected. I think Rakesh was first. Elias, unless you were typing in. Oh no, Kyle had A. Oh, I saw an A. There's an A. There's an A. Oh, never mind. There's a bunch of A's. Let's try A's first. Okay, cool. All right, so A is the right answer. Now, just to say this is that we probably wouldn't do this now with a large amount of VPCs. You use something called transit gateway instead of using VPC peering, but we'll talk about that when we get to it. So here's the problem. Just because B is connected to A and B is connected to C doesn't mean that A and C can talk to each other. Amazon does not allow transitive peering inside of their networks. So they will not allow you to traverse one VPC to get to another VPC. I don't know why. It's probably because of issues with like, spanning tree or some variation thereof. I have no idea what the reasoning is, but they avoid it like the plague. So instead, you would create a new connection between dev and prod so they can push code to each other, right? And it is actually recommended that you either at least use a hub and spoke model or you do a fully mesh network for VPC peering. The problem is that when you get 500 VPCs, you're going to get a lot of connections. So this is where the other service transit gateway comes in, which can actually connect VPCs and VPNs and all kinds of stuff together a lot easier, right? So the best answer here is actually create a new connection. But it does actually have, at scale, a lot of operational overhead. But in this case, since there's only 3 of them, doesn't matter. If that question said 500, we'd probably be looking for another answer. Because honestly, even with like a dozen, it's a pain in the rear end. So operationally, so we'd probably be looking at something else. You can't do nothing because the transitive peering doesn't work. You definitely don't want them to have overlapping CIDR blocks. If you have overlapping CIDR blocks, by the way, like let's say one VPC thinks it's 10.1 and another one thinks it's 10.1, they'll never find each other because they both think that they're 10.1. Right? So one won't route to the other because they won't be able to know. There's no differentiation between them. And then create a new entry in prod in the dev routing table using the V. That's not how that works. So that one's just wrong. Okay. A company has an on-demand EC2 instance located in a subnet in AWS that hosts a web application. The security group attached to this EC2 instance has the following inbound rules. So it looks like it's SSH, wide open on inbound. The route table attached to the VPC is shown below, and you can establish an SSH connection into the instance from the internet. However, you are not able to connect to the web server using your Chrome browser. What would you do to fix it so that you could get to that instance from your Chrome browser? Good. There's a lot of B's here. I mean, there's no rule that actually says that like web traffic can actually get to the box. So it's not going to work actually. That's true, Dave. Good point. Well, there was no, it did say, web traffic, right? In your Chrome browser, but you're right. It should be HTTPS, but we're just going to pretend. Notice here that they actually did add like 443 traffic. So it's funny. I don't know why they put custom there though. Huh. Weird. All right, next one. Local bank has an in-house app that handles financially sensitive data in a private subnet. After the data is processed by the EC2 worker instances, it is delivered to S3 for ingestion by other services. How should you design the solution so that data does not pass to the public internet? So I'm gonna let you read this one, but this one we haven't covered either. And it has to do with how you keep traffic off of the internet. Okay, I'm seeing some A's here. So I have a question for both David and Dave. Tell me what a VPC endpoint does.
What do you mean? Can you, how do you mean VPC endpoint?
What does a VPC endpoint do? Could
Sure,
you-
it's an interface for accessing the VPC.
Well, how would that help with data? Like, how would that avoid the internet? How would that help with data going directly to S3?
So it allows you to actually say from this VPC to this particular service over a private network, so you don't ever have to specify a public range, is my understanding.
That's perfect, actually. That's well said. Good. Thank you for answering while after being put on the spot. All right. So let's say you got a VPC over here, right? And you've got your like EC2 instance that's, you know, inside of it. And it's on, you know, let's say, let's use pink for this one. Let's say it's on a private subnet. And you don't want to send, and by the way, meanwhile, out here, out in the same region, in the regional data center, you've got S3 buckets. This is all in the same region, by the way. Now, normally your traffic would actually go out to the internet. Wow, that's not at all what I wanted. Your traffic would go out to the internet and then hit the S3 bucket. Even though you're in the same region, let's be clear. Your data centers for your EC2 instances are distinct from the data centers for the region. So you would go out the internet, but let's say you didn't want to do that. So what Dave and David are suggesting is that instead of doing that, what if there was a way for you to go over AWS's private backbone, not go across the internet? Well, there is actually. They're called VPC endpoints. And you have to make a VPC endpoint for every single service that you want to use for this. But what would happen is this EC2 instance would talk to the VPC endpoint, and the VPC endpoint would have a private tunnel out to the public S3 service. So no going out to the internet to do this. Instead, you just go out the private tunnel. And that's what a VPC endpoint is. It's a private tunnel. It's a private endpoint in the VPC that allows you to talk privately to public services like DynamoDB, S3. They have gateway and interface endpoints. So we're going to cover this when we cover networking 2 on like day 3, maybe early day 4. But don't worry, we're going to cover this in detail. So you're going to get understanding a little bit more about what it is.
But to be fair, it was a lot easier just to say that the other ones were more wrong.
And that's also a legit answer.
It was not expertise in any way.
Exclusion works, Dave. I just want to make sure we're clear. I've answered many a question that way. Okay. So we'll talk about VPC endpoints and transit gateways when we get to the second section on networking.
Right, before we move on real quick, is that for AWS services only within my AWS account? Like the VPC endpoint can talk to other AWS services within one account, is that correct?
Yes, although private link, which uses the same technology as VPCs, can actually talk to services and other accounts.
Got it.
Yeah. So private link, which is the underlying service that makes VPC endpoints work, you can actually talk to other people's like load balancers and stuff. So
Gotcha.
the official services, the answer is yes. If you want to, like, if Salesforce all of a sudden publishes an API, and you want to talk to that privately and they're in AWS, you can actually do that using a VPC endpoint using private link.
Sweet.
Yeah. All right, last question. I think it's the last question. Yeah. Get a web app. It's on a Linux Amazon EC2 instance in the public subnet. It uses the default network ACL. So you got to remember what that was. The instance uses a default security group. You got to remember what that was too. And has an attached elastic IP address. The network ACL has been configured to block all traffic to the instance. Well, that doesn't sound like the default. And the SA must now allow incoming traffic on port 443 to access the application from any source. So what has to change with both the network ACL and the security group in order for 443 to come in to the instance? So you gotta select 2. Okay. I'm seeing a lot of E's. I'm seeing a lot of A's too. And a lot of C's. Okay. So I'm going to choose A because that looks like the next most popular one. Right? Okay. So what needed to happen here? Let's take this step by step. First of all, if we have a default security group, then by default, all outbound traffic is allowed. All inbound traffic is what? If we have a default security group, inbound traffic on a security group is what by default?
It's denied.
Denied. So A is definitely correct, right?
Yep.
Because we're basically saying, look, we want to add a new rule to allow TCP connections on port 443 from source, blah, blah, right? Because remember, we are receiving those connections. So we need to make sure the source is anybody. We're not sending those connections out, we're receiving them, right? So we need to make sure the source is anybody we want. So that's the first thing. And it's on 443, so that's accurate. So that takes care of the security group because outbound is going to happen by default. We're not worried about that. Now, here's the thing where it gets a little weird. Because NACLs are stateless, you have to have 2 rules, one for initiating and one for responding. I know that sounds weird, but because the NACL is not tracking connections, it evaluates all traffic as if it's never seen it before. It has like permanent short timers. Like you're literally like, I just initiated traffic with this guy. And it's like, well, I don't remember that. So I don't know what to do with your traffic. So I'm going to block it. Unless you give it a rule that says, hey, by the way, I can both send 443 and I can respond to 443. You need rules for both. Because remember, this is stateless. Now, this is where I think most of you had that concept correct. But then this is where things get weird. When you allow an inbound connection on port 443, you're probably going to respond or ask us to move to a different port. Otherwise, you're going to keep that port bound, are you not?
Mm-hmm.
So your outbound connections are probably actually going to be on a different port. And that's just the way that the networking stack functions. So this is a little bit of networking stack operations as well, right? Because you're not going to sit there and just constantly talk on 443. You're probably going to use other ports on the stack as well.
So there's no way to specify that like an ephemeral port. You would have to put a whole range, like a
well, those are ephemeral ports. So by default, Kyle, like that's the behavior it's going to execute, right? Is this going to pick a random port in this range and send outbound traffic to it, right?
Right. Yeah, that I understand. I mean, it's like instead of like a rule where you can kind of hit dynamic, you kind of allow this whole range, or is that just something with this question maybe?
In other words, what's happening is that you are allowing outbound on any number that's between these ranges, right?
Right.
Now, could you go back to your, let's say web server and say, look, you can, I only want you to initiate outbound on this like certain subset of ports. I'm sure you could, but the default behavior for the Linux kernel is just going to be respond like in that range. It's going to respond between 32,000 and 65,000, basically. So this is one of those behaviors you're just going to have to know, right? And he explains that same thing about the designated ephemeral port, right, for return traffic. So you could actually like control that. You could like go in the Linux kernel or force the application to respond on a certain port. But note that these are some of the ephemeral port ranges that they're going to want, kind of expect you to kind of have like in the back of your head. I've never been asked anything about the Windows ephemeral ranges, but I have been asked about the NAT gateway, about the Linux kernel, and about the elastic load balancers. So
yeah, that's kind of what my question was instead of, you know, saying for the rule that it's a dynamic or ephemeral port of a certain type, you kind of like, or manually typing in the range. But I understand what's trying to happen.
Yeah. Yeah, unfortunately, NACLs are really simple. So you have to give them the range. It'd be nice if you could just say, hey, this rule talks to an elastic load balancer. And it would just be like, oh, okay, so then it's going to, or it's talking to a Linux kernel. So it's just going to respond on that range, you know, but because it's a really simple firewall, it wouldn't fill that in for you automatically.
Got it.
Yeah. But you see the huge business gap there. So I would like 1% of all amazing earnings that you make from your future business that you start off that concept to solve that problem. All right, good. Any other questions or comments? Okay. That was our last one. Okay, so we got 5 minutes left. So let's talk about what we're going to talk about tomorrow. We won't actually talk about it because we got 5 minutes left, which is fine. This is totally where we were supposed to land, so there's no issue here. Because we're sneaking in the certification kind of prep as we're going along, right? So tomorrow, sans all of this. Tomorrow, we're going to talk about compute, and we're going to do a lab right off the bat. So just know that tomorrow is probably going to be, you know, we're going to do 2 labs tomorrow, possibly 3. So just be forewarned that we might spend a little bit more time in labs than we usually have, which most people thoroughly enjoy. So that's usually not a problem for most people. But tomorrow, what we're going to do is we're going to talk about compute. So I'm going to talk mainly about EC2, a little bit about Lambda and some of the associated stuff around licensing types and whatnot. And then I'm going to talk about storage. And we're going to do a lab in the morning as well. And then I'll probably talk about storage, about mounted storage and then object storage. So we're going to talk about S3, we're going to talk about EFS, we're going to talk about EBS. And then we'll end the day talking about database services, and then we'll do a lab. And depending on where the lab lands us, we probably will get into monitoring and scaling. So we'll talk about auto scaling groups in CloudWatch, and we might get to the lab tomorrow, might not. And then what will happen is then on day 3 and 4, we'll do automation containers, networking 2, and serverless. And then the last day will end with edge services, backup and recovery, and the capstone project. Before we actually do the capstone project, just so you're aware, I'm going to spend about 30 minutes to an hour talking about training and about how to use some of the resources that I'm going to share with you to prep and get ready for the exam. So just know that before you leave, we will make sure, even before we do the capstone project, that you are fully versed on the steps that you're going to want to take to take and pass the exam. Okay. So tomorrow will be compute, storage, database services, possibly monitoring and scaling. Does anyone have any burning questions or anything logistical or otherwise that they want to ask me before we get off for the day? No? Okay. Well, let's be done. Get a few minutes back. I'll see you bright and early at 8:30 Central, 9:30 Eastern time. And so we'll pick up where we left off and we'll go from there. The recordings, by the way, are typically posted by noon the next day. I apologize for that. It just takes Zoom a while to do the processing. But as soon as I get a link, I will share it out with you. So first thing I'll see you in the morning, I'll post it as soon as it's ready. Okay. All right, y'all. We'll see you tomorrow.
Thank you, Michael.
Thank you.
I do.
Thank you.
Thank you. This is great.